on. So this is the way OpenST Linux is released and supported. Again, after the support is still available from partners. Now, the software tools offer. It's an STM32, so no surprise, we find Stm32 Qbi, we find Stm32 Qbi, and Stm32 Qprogrammer there. The Stm32 Qbi is used for the device tree configuration and generation, so it's a configuration tool. You can use Qbi for the development of your application, and you can also use the programmer. Please note that you have some of the security elements of the STM32 ecosystem that is using STM32 Qprogrammer. So basically, the STM32 MP1 is an STM32. Now, let's talk a little bit about the OpenST Linux from a distribution and package point of view. You have one distribution and 3 packages. We have a starter packages. The starter packages is to quickly and easily start. Basically, you are getting a package for a given board with a given microcontroller. You take that, you take the STM32 tools, you program this is in one of the STM32 boards. I'm going to talk about the board just after, but you take one board, you take the starter package, the tools, you program the starter package in your board, and you have a Linux environment running on an STM32 MP1 to get started. Now, if now you need to develop some of your application, keeping most of the starter package elements, I mean a given kernel, etc., then you can start from the developers package. This will give you the flexibility and the SDK to do your own development. Now, if you want to have full control, everything available for you, then you can use the distribution package, and that distribution package is leveraging Yocto, and basically we gave you everything, all the source code you need and the scripts you need to create your own Linux distributions. You can even generate your own starter package and your own developers package from that. So one distribution, 3 different packages depending on what you are looking forward to do. The evaluation platforms, again, it's an STM32, so you have the eval boards and the discovery kits. The discovery kits come in 2 flavors. You have one flavor without a display, and you have one flavor with a display and a Wi-Fi module. And then you have all the hardware available from the partners. So I told you at the very beginning that I'm gonna go through an interesting use case of how you can leverage both OpenST Linux as well as some of the Rtos Thread ecosystem. We have a flexible platform here with a Cortex-A and a Cortex-M. So OpenST Linux is gonna run on the Cortex-A, and I'm gonna have Rtos Thread running on the Cortex-M. So if we look at the block diagram, so this is the first slide of that presentation with the block diagram. So you have the dual Cortex-A core here. We have the Cortex-M4 cores, and then we have all the peripherals about connectivity, analog, control with the timers, security, and all the systems, not to forget the GPU. So in that use cases, I'm going to have an OpenST Linux distribution running on the Cortex-A, and I'm going to have Rtos Thread running on the Cortex-M. Now, what is it that the Rtos Thread can access? What is it that is more on the OpenST Linux side? So if you look at here, you see the list of the IPs that are supported by Rtos Thread. So all the IPs you see with the red outline are the IPs that have been ported on Rtos Thread. So you can have connectivities. Let's say I have some sensors. I want to use the I2C or the SPIs. They are available. I want to do motor control. It's available. I want to do a little bit of AES on the other side. That is available. Analog available as well. So basically everything that you would need to make real-time thing is going to be available on the Cortex-M4 with the porting that was done by Rtos Thread. The graphics, as well as some of the configuration, is still going to be under the dual Cortex A7 control. But basically, this is an overview of the hardware. Now, I have two systems. I have OpenST Linux and I have Rtos Thread. How does this system start? Let's have a look at the boot sequence. Basically, what you see here is that you start on the Cortex A7. So you have the boot chain here with the secure boot here, as well as TFA, and then you have your U-boot stage. Then your application is you have the runtime services with the trust zone architecture with some secure and non-secure domain on the Cortex S7. And then you have the Cortex M4 side. And that Cortex M4 side is what is running Rtos Thread, and you can start it from U-boot, but you can also have Linux starting it, either at the second step or at the second stage, or you use remote proc in order to load from the Linux kernel. Another element that is interesting and that is showing the actual flexibility of the platform is the communication between OpenST Linux and Rtos Thread. So you have the Cortex A7 that is going to load the Rtos Thread, and then through some shared memory and a dedicated IP, you're going to have some communication between the two. Little more on that after. You can also assign you have a static allocation of the peripherals. So if you, let's say, want to have some sensors on the Cortex M4 side, then you can assign an I2C or an SPI there. You may want to keep the CAN on the Cortex A7 side if you want to do communication. Let's have a look now a little bit at how the software is working, both on the Cortex A7 side and the Cortex M side. So on the Cortex A7, we are using well-known software packages to do that. We are using remote proc to control the loading of the Rtos Thread package, and then we are using RP message and Virt.io for the communication. This is what you see here as well as here. Loading and control being by the remote proc. If I look at the Cortex M4 side, we are using OpenAMP. In fact, Rtos Thread did the porting of OpenAMP on the Cortex M4 side in order to be able to use it when communicating with the Cortex A7. I will not go into the details of everything about OpenAMP project, but you have some links here that you can refer to if you want more details. So basically here you have a couple of information regarding the communication between the two. One more important point is about the debug. The debug side, you have the Cortex A debug That's where you're going to find STM32 Qbi. For example, you will manage your Linux project, and you can use ST-Link to debug the Cortex-A. The development on the Cortex-M side of Thread is going to be through some third-party IDs. So ST has validated the implementation using IR. Thread also has an implementation using Kill. And the debugging is going to be done through the UART. So I just wanted to give a little bit of information regarding how the debug is working in that multi-project architecture. And what you have here is a simple introduction about how to load Thread thanks to remote proc. So you can see here Thread is running on the platform. You start it and stop it. So this is actually working. I just gave a quick overview of that. If you are interested in that solution, here are some references. I put some references on the coprocessor management. In fact, this is available on the STM32 wiki. And you have a lot of other information on the STM32 MP1 wiki as well. And also, I put some resources on Thread. So one point I want to highlight here is that Thread is not part of the default open ST Linux distributions, but you can get the source code through GitHub and then get the open ST Linux distribution from st.com. You build them, you integrate them together, and you are good to go. ST did the validation of that, so that's actually an interesting use case if you are looking for both high performance on the S7 and as well real time on a Cortex-M. Okay, so in this part, I'm gonna talk about STM32 Qbi. This is an optimized ecosystem, an optimized AI ecosystem for the STM32 microcontroller, for the STM32 MCUs. But before going into the details of what STM32 Qube.ai is, I want to go through the key steps behind the neural networks. So first, you need to capture some data. That is the step one. Once you have those data, you clean them, you choose a neural network topology. That is your step two. Then you train your model with those level data. That is the step three. This is the model creation. Now, starting from step four, that's where you can use STM32 Qbi. The step four is to convert this neural network into something that is optimized for a microcontroller. Then you process those data. Basically, you load everything inside your microcontroller in the step 5, and you run your algorithm on the target. So Qbi is the step 4 plus 5. Qbi is a tool for teams with some AI expertise. Why I'm saying that? Because you developed and you train your model with one of those major frameworks. So I mentioned TensorFlow, you have scikit-learn, PyTorch, etc. So you need to know how to use those tools. And then that's where Qbi for the step 4 and the step 5 get into the picture. That's where you will get the best performances. That's where you will be able to validate the performances and do this on most of our portfolio. Cortex M0, M0 Plus, M4, M33, and M7. If we look at the same thing a little bit from a different perspective. So this on the left, these are the step 1 and 3. these on the right are the step 4 and the step 5. So you use your major AI framework, or you can use scikit-learn. You export it to ONNX format, and then you put this into Cube.ai. Cube.ai will let you select the most appropriate MCU. And you will be able to review as well a lot of the memory consumption layer by layer. That is, I have a slide on that that is very interesting. And then you put this into the STM32. You can validate and you can fine-tune it. This is the workflow to implement neural network and machine learning on STM32. Now, let's pause for a moment and look at the STM32 portfolio and our AI solutions. So STM32 Qbi is available with the latest version, the version 7.1 is available on Cortex-M0, M0 Plus, M4, M33, and M7. So basically, it makes it available for most of our portfolio, including the latest U5, but as well as our high-performance MCU. We also have another tool that is NanoEdge AI Studio. That one is able to work on our complete portfolio. So it's a different offer. I will not go into the details, but definitely check it out if you are interested in AI. We also have some Linux package for the STM32 MP1. So let's go back to STM32 Qbi. Couple of main features. I want to dimension my system so I can select quickly and configure a microcontroller within Qbi. I can review some of the model layers. Then I optimize it. We are optimizing all the elements that can be optimized on the system. The memory, the code execution, we support quantized models. We optimize for performance. We optimize for RAM usage. We use light runtime libraries. And then you fine-tune it. You can split, for example, between internal and external memory, depending on how your architecture is done. Or if you want to compare internal versus external memory. This is all the features of STM32 Qbi. And it is available both as a graphical and a command line interface tool. Another interesting about STM32 Qbi or more about AI on the STM32 is that you can have a flexible implementation when you run TensorFlow directly on the STM32, or you can go for the more optimized approach where you run, you use Qbi, and what you run on the STM32 is actually the output library that run only on STM32, by the way, because we optimize it for our product. And this is where you're going to have a really optimized model running on your target. I will come back a little bit of the performance and the difference of the performance between these two in the next part of my presentation. Fine-tuning. So STM32 Qbi, as I said, you can see the memory, the RAM consumption for each and every layers. That's what you have here on the left. You can also have advanced settings, enabling the use of external memory, enabling the use of non-contiguous external memory. You can even optimize input buffer to reuse them as activation buffer at runtime. All those types of configuration is available for you to fine-tune your implementation on the STM32. Very powerful tools here. But this is just an introduction. This is just an overview. If you want, you can get more tools and documentation from st.com website. I just mentioned, I'm talking for 5-10 minutes now about performance optimization. Let's have a look. So I just presented that slide already when you have TensorFlow lights running on the STM32 on the left and the library being optimized by Qbi on the right. So I can take one model, run it on both strategy, and then see what the outcome is. And that is exactly what we did. So what you have here are two models, one of image classification, one of visual wake word, running on two different platforms, a U5 microcontroller for the first model and an H7 microcontroller for the second model. The first row is the Xcube.ai optimized library running on the target. The second line is TensorFlow Lite interpreter running on the target. And what you can see is that in both examples, we get faster inference time, smaller flash, smaller RAM. So I just wanted to have a little bit of data just to show you the type of performance gain you can get on when using STM32 Qbi. And in fact, this is also one of the reasons why Rtos Thread is using STM32 Qbi. So that's what I want to talk a little bit now, is that how is Rtos Thread in their AI kit using STM32 Qbi. So if you remember my first slide about the steps, so you have the step 1, 2, 3 that are at the bottom part of your flow. So you start to look at this slide from the bottom left. You use PyTorch TensorFlow, you build your model, you train your model. Step 1, 2, 3. Then step 4 is you are using an AI kit tool to optimize your model for the target. And what Rtos Thread AI Toolkit is doing is they are using STM32 Qbi. They are using the command line version in order to leverage the optimized performances. And what you get is the Rtos Thread environment with both an optimized AI as well as all the other elements, operating system, etc. So this is the tool set part. Now, if we look at the embedded software part, that's where we get an STM32 target device here, running the optimized Cube.ai library. We have the Rtos Thread APIs, and you have your model running on top. This is another example, this is another very interesting example on how the STM32 Qbi is being leveraged by an external tool like RTAK, for example. Okay, so let's have a look at a couple of references for what we saw about this RT AI kit and STM32 Qbi. So here I listed 3 GitHub repositories where you can find some of those examples. Most of them are using the ArtPy, which is the board you can see on the right. Short takeaway, we talk about STM32 MP1, its flexible architecture. We talk about its ecosystem being an STM32. We talk about Rtos Thread and OpenST Linux running on an STM32 MP15, with OpenST Linux running on the Cortex A7 and Thread running on the Cortex M4. And I touch a little bit on the STM32 AI. We are making AI on all our portfolio. NanoEdge AI Studio is being one tool. I didn't talk too much about that one, but I recommend you to check it out. And I show a little bit more about STM32 Qbi and the optimization it brings to the table. And the last diagram shows how another use case of Thread and STM32 being used together on an STM32 to bring the best to our customers. And for sure, if you want more inputs on the MPU or the AI solution from ST, you can always get to st.com. So thanks a lot for your time. I hope you enjoy the rest of the developers conference. Thanks again. Have a nice day and take care.
Well, thanks to Stefan for the recording. I'm sorry about the poor quality of the sound. Sometimes these things are just set up to go wrong. Who knows why? Okay, our final speaker before our first break is Robert Ling. Robert is the Senior Technical Manager at Nuvoton Technology Incorporation, and he has more than 20 years of experience in microcontroller, microprocessor products and marketing planning in the semiconductor industry. Robert is responsible for the market operation and business development of IoT security MCU products at Nuvoton. And the topic of Robert's talk is Unleash the RT Thread Power by New Micro M2354 series. So, Robert, over to you.
Hello, can you hear me? Hello?
Yes, we can hear you. You're
Okay.
a little bit faint.
Okay, how about this?
Speak louder.
Louder. Okay, I believe this is better, right?
Yes, that's pretty good. Thank you.
Okay, thank you. Yep. Okay, so I can start my presentation, or you need to do some introduction, more introduction?
No, you're ready to start.
Okay, thank you. Thanks for your introduction, and let me show my screen as soon as possible. Okay. Yes. Thanks the invitation from RT Thread, and I'm so pleased and honorable to be invited to join this event and give a presentation. My topic is Unleash the RT Thread IoT OS Power by New Micro M2354 series. Again, this is Robert Ling. I am working with Nuvoton, belonging to microcontroller.
Robert, we can't see your slides. We can't see your screen.
Okay, sorry.
There's a share button at the top of the Teams interface next to the microphone symbol.
Yeah. Okay. How about this?
Yes, now you need to go into presentation mode, I think. Yes.
So, okay. Sorry for a bit the problem in the beginning. Okay.
No worries.
Yeah. So let's start my presentation now. Okay, this is my agenda today. I would like to give you an overview update of IoT security market as our findings in this year or past few years. And I would like to mention a bit security threats to IoT environment, and then our new micro family IoT platform solutions. And the point is the M2354 series at a glance. And finally, it's a conclusion from RT Thread to multi-cloud support for IoT node devices. I won't be so deep technically, but I will give you an overview to Pneumaton IoT security platform, and then focus on IoT security series M2354. Here we can see the challenges to IoT business. We believe this is the most challenging to IoT devices is security, because the use of cloud technology technologies continue to grow to billion of new devices with different capability, and many of them are physical accessible and thus exposed and vulnerable to attack or be misused. And digital identity are needed to prove the ownership. So on the other hand, the most recently our observation is growing IoT security regulations worldwide. So you can see the most challenges will be security threats in IoT era. And what's the global IoT security market from 2020 to 2025? Although we experienced COVID-19 in past 2 years, so you can see a little bit slow or keep flat in 2021 or 2022. But we foresee soon the IoT devices or IoT services will take off. So it will be a CAGR almost 24% yearly. So and in terms of geographical growth, we can see the top 3 areas is Europe, North America, and Asia Pacific. Especially for Asia Pacific, there's a big momentum, but we believe most pioneer or leading or innovative applications will be created from Europe or North America. Then we will see the more mass devices or volume zone applications will happen in Asia Pacific. So this is give you a illustration after our internal investigation. Okay, and what's the importance of IoT security? And we need to start the discussion from security threats. Firstly, we can see the unsafe communication and unauthorized access will be the first the first place or first to be highlighted for IoT security. And this unsafe communication or unauthorized access will cover in eavesdropping, spoofing, and tampering with data. So here is an example. This is an IoT device example hydrometer, and it will regularly report the data or status to the cloud service. And in the internet in the middle way, internet, it will go through gateway and network. So when the data is transmitted from devices to cloud service, you will be facing injection, malicious codes, or tampering with data, or even the devices to be cloned. So this is a dangerous or the impact to a IoT devices, meaning security issues. And how do we protect the connection? And here listed some solutions like SSL or TLX and digital certificate, symmetric or asymmetric key stream authentication. So to provide these protection approaches, the MCU needs security features. So here we say the security blocks from MCU. So more and more requirement to MCU will need will be security storage. This is for unique ID certificates. These certificates and keys, and unpredictable random number generator to generate a key for data encryption or decryption. Then better to have a cryptography accelerator in hardware, since the efficiency is far comparing software and hardware approach. And for common IoT security threat number 2 will be compromised IoT devices. Like the network becomes facing a botnet attack, malware attack, and so here we'll need more security functions, especially for hardware and software integrated solution, covering secure boot and secure OTA. And for the previous slide, the secure storage or crypto accelerator also needed. And trust zone can benefit the firmware or software inside of MCU to be more protected. Yeah, and we also need more serious OTP life cycle management, like to use a OTP, one-time programming memory. This is the third part, physical attack to IoT security threats. For physical attack, physical tampering, like JTAG and the debug interface access and the MCU clock or even voltage pins to be inject the glitches or bad signals. And how to mitigate these attacks? So here the MCU may need the physical tampering detection or protect the flash memory. Just so long it can also work. And for clock and voltage fault injection, we do need implement the clock monitoring and the voltage glitch detection. And I believe this is more and more required for general purpose MCU, or we say the IoT MCU, even it's a traditionally secure element product have. Here we talk about the MCU security target. In overall, we can say MCU security target, especially for network connected devices, it's to implement the security features to define against software attacks and the non-invasive hardware attacks. I should say the IoT security is still in developing stage from time to time. Most people are a little bit confused how to categorize traditional secure element, or we say the smart card chip, the security label, and the general purpose MCU security label. After several years development and experience from our side, we believe in IoT or medical or other some general purpose applications. It do need the software attacks protection and the non-invasive hardware attacks, covering side channel attack, for injection attack, protection capability. If we talk about the invasive hardware attacks, we think it's almost belong to the traditional payment applications or online banking related. We don't believe this will be so necessary for IoT MCU or general purpose MCU. As I say, the more and more IoT security regulation has been created from different countries or areas. And this is a summary for current progress of IoT security related certifications worldwide. You can see integrate sufficient security feature.
Hey everyone, the meeting just ended totally unexpectedly. So I'm seeing all sorts of messages all over the place. We're desperately rushing here to get everything back on track. So while we're waiting, how's everyone enjoying it so far? Did you have any questions at all that, apart from the fact that you were disconnected and why, that you'd like to share, or any comments on the conference? A bad day for a conference. Oh dear, these things are sent to try us. I don't know. Well, one thing I was thinking about, so I've just got a message that says Robert will be joining us presently. He's just trying to find his own way back in. Yesterday, somebody was talking about autonomy, sort of like robots and things from the past. And there's one that I looked up that it featured in the film Hugo. I don't know if you saw that film, but it was really amazing, because I thought when I first saw it that it was all fiction, and it turned out that just about everything in the film was based on the real world. And I'm just posting a link here to something from 250 years ago. It's a mechanical robot called the Rtos that was programmable. So you could program it to write what you wanted, and it writes in cursive, you know, the curly script, which is pretty fantastic to see it working. There's a video as well. Yeah, I included the link to the YouTube video. It's well worth watching. So hopefully Robert's going to be able to join us shortly. So Giorgio says, very good material today, but it's a pain to watch/listen. Is that, are we talking about the one earlier on, the recorded video, where it was the very poor sound quality? Because I agree that can be very hard to listen to. And the people at RT Thread are working furiously to correct for the sound problems. I know that. Do we have any fans of Doctor Who? Apart from me. Ah. Okay. Well, I'm I've just got a comment to say, wait, he's coming soon. Okay, the thumbnail image. All these comments, the folks at RT Thread are watching them, and anything like this, it takes a huge amount of effort to put on. And each time you learn how to do things better. So, yeah, we'll carry on with what we've got at the moment, and hopefully next year we'll blow you away with the latest and greatest in technology. Come on, Robert, we're waiting for you. And then after Robert, let me see where we are here. So after Robert, we've got our first development board giveaway of the day. Oh, Kathy says, let's do the giveaway now. So while we're waiting for Robert, so that's fair enough. So this will be the first giveaway of the day. And the winner, so the first winner of today is the person who entered at the end of the day yesterday. And I'm just going to post the name up here. Right, so here's the winner. This is from yesterday. So we're having 3 development board giveaways a day. And Sepha, I think. Congratulations, Sepha. Each time it's a different board. And then we're going to have a super dip at the end of the conference and the lucky winner of that will get one each of all of the development boards. And Kathy's just posted a link here, and this is for the next giveaway. So this is a great time while we're waiting to click that link. I'm not going to do it, of course. And we'll announce the next giveaway. Well, we've got one break after Robert, a 10-minute break, and that's when this giveaway should have been going on. But we'll give the next board away at the second break of the day. So let's hope Sepha knows that she's won, or he's won. Okay, and there's a good suggestion from Georgiev. For next year, it would be great to organise access to the slides. especially for the technical presentations with many links. Well, I can't fault that. Can't disagree with that. So still waiting for Robert. While we're waiting, has anyone played with virtual reality? I'm a big fan of all of this technology. I was right at the front of the queue for the very first Oculus Rift. It's hard to believe that was in 2016 now. What event is tied to the countdown clock? That's an interesting question. It said that it's not counting down, it's counting up. Unless you're seeing a different countdown clock. So Peter, can you post which countdown clock are you talking about? From the dip. I don't know what a dip is, sorry. Let me just query. It's from Kathy's link after you type your name. Oh, I don't know. So Kathy, if you're listening to this, Peter's asking what events tied to the countdown clock, and it's on your link. When you click on the link that you provided for the lucky dip, after you type your name, apparently there's a countdown clock, and Peter's asking what event is tied to the countdown clock. Just looks like a 212 days timer. Well, the classic 212 days timer, eh? Ignore the countdown. Are you holding jump blades? Ah, that picture. Yes, but it is photoshopped, of course. So the question was, am I holding jump leads in the picture behind me? Doing an Elvis impression or a mad scientist. This was a couple of years ago. I just got tired of seeing all of the profile pictures where you had the person doing the thinking man type pose. So the office that I was working in, or where I rent my office, there was a graphic artist next door, and I said I wanted a slightly different picture, and so he told me to put a white coat on, and I got my steampunk glasses and a couple of car leads, and off we went. Just he put the lightning in. It's not really electricity, of course. And then I don't know if you can see the other picture up there, but that's the way he said he always saw me. He'd be walking past my office door, and he'd see me looking at my computer monitors. And he just took that snap and he posterized it. Well, thank you. I'm quite proud of it as a picture. So virtual reality, yes. I did quite a lot of work with virtual reality, writing for companies that were doing it for the military, but those systems cost hundreds of thousands of dollars. This was like 2005 or so. And when I heard that the Oculus Rift was being developed, I signed up for it at once. And when it first came out, it was just mind-blowing. Of course, it was a pain. The original Oculus Rift required a humongous computer, which limited your motion. But again, that's
to give a quick review from the beginning, then move to the points. I want to focus the topic M2354 series. Sorry for this problem. Could you see my screen?
At the minute, we're just seeing the Microsoft Teams screen, not the. There we go. And now, if we go into presentation mode.
Okay. I believe you can see it, right?
We're seeing the power. That's showing us the PowerPoint interface, but not the presentation mode. When you go into presentation mode, I think it's throwing you to a different screen.
But I saw the screen. Oh, I saw the sharing screen now. How about you?
We can see PowerPoint.
Yeah. Okay.
Okay, now, Ivo, you're saying that you weren't sure where you'd broken off, but Ivo says it was the slide with the table of security measures in the 3 categories. That's where you got to. Oh, and somebody says press function key F5.
No. I think it's a network delay or some problems. Okay. Okay. One second.
Several people are saying press function key F5 in PowerPoint.
Oh, sorry.
Okay, somebody's saying stop the share, go to presentation mode, and then share the screen.
Yeah. Yes. Okay.
In the interest of time, Robert, maybe just leave it the way it is and just scroll through the presentation the way it is, and we'll just make do. Maybe we can share the PowerPoint slides later.
Yeah. Okay. How about this?
Yes.
Sorry. Oh, so it's a long journey. Okay.
Okay, like I say, somebody says, Ivo says that you were at the slide with the table of security measures in the 3 categories.
Okay. Here? Correct?
That's where I remember as being, yeah.
Okay. Yeah, let me continue. And it's a lot of time for, wasted. I'm sorry. Let me quickly to go through this slide, and I promise to provide the file for your public download. For MCU security target, we want to highlight to implement the security feature to defend against the software attacks and the non-invasive hardware attacks. This we are including they were including software attacks and non-invasive hardware attacks protection approaches. And for those attacks is highly related to IoT, medical, and other MCU applications. And for traditional payment application or even for online banking related hardware dongle devices, they might need invasive hardware attacks mitigation approaches. These attacks may be conducted by microprobing, focus ion beam, FIB, etc. So these attacks need more high expertise or a special premise for example, in a laboratory. This is a current progress of IoT security related certification compared to different applications and different security standard sponsored or regulated organizations covering like a CC, common criteria, global platform CC profile, PSA initiated by ARM, CSPN, mainly initiated from France. For industry, there is IEC 62443. Okay, here is a overall summary and explanation to Nemotron one-stop IoT solution, covering device platform, device ready, gateway platform, cloud ready, companion application on a mobile phone. I listed the slide here to explain Nemotron provide our product portfolio covering MCU and the MPU products with certain software solutions, including driver for connectivity for different wireless protocols, and gateway reference design mainly by our MPU product. And for different clouds, we have several different cloud connection example. Even we created the companion apps on monitor on our mobile phone. Here is a summary. We categorize the IoT platform from IoT device platform, IoT gateway, and out-of-band platform for server. This is out-of-band platform for server is a industrial industrial applications, mainly for servers located in cloud center or database center to monitor the cloud the server for cloud services for remote control. And it also support a security link remotely. Here is overall explanation to our Monochrome IoT platform from hardware MCU to our partner from RF wireless communication vendors and the OS vendors and the cloud vendors as a detailed explanation from my previous 2 slides. Okay, so let's move to the points today at the M2354X series. We provide the different security feature from the security label point of view. From the M26X, the basic security functions required for general purpose MCU in the IoT era, secure boot, and the M2351 with incremented secure connectivity covering the RTOS libraries and the firmware OTA and the product lifecycle management. And finally, M2354 with secure storage. Here I explain the PSA a little bit. Why we choose PSA to be a guideline of when we design our IoT security products, because we think this is a good reference standard for building a secure system and the reference implementation. You know, security is not easy to be defined, so we think it's necessary to have a common language for IoT industry. And this is a good example, provide an approach from analyze, architect to implement. And in terms of common principle across multiple use cases, this provide device identity, trust boot, and the secure OTA and the certificate based on authentication. So this is a good software architecture hardware requirement guideline for IoT devices from the chip to system label. So with the PSA guideline and our in-house technology, we developed our M235X IoT security controller from the first generation M2351 to M2354. The focus is M2354. We innovate. I'm proud of to say we invent the secure key store with inside of the MCU, inside of SoC. This secure key store surrounded by crypto power side channel mitigation approaches, platform security mechanism, certification support for IoT ecosystem, and the internal data transmission with scramble technique. So I think this is the most economic solution to IoT industry, especially for node device design, because you can save a secure element cost even and the complex secure element development procedures with certain level and security guaranteed key store inside of an MCU. We try to enhance our IoT security platform with Thread by end of this year to announce our M2354 IoT platform with Thread combined with TFM, Trusted Firmware M. This M means for Cortex MCU, Cortex M. Cortex M label MCU. So we hope it can finish this job by end of Q4. Actually, I think we can announce this with Artistrade in Q4 together to announce the maybe this is the first platform with Artistrade and the TFM solution global globally. So for the detail, you can check the download file later. Finally, let's move to the conclusion. We try to from Artistrade to support multi cloud. So here you can see in our M2354, the latest IoT security platform, we will focus on Artistrade more than other embedded operating systems. And we can leverage our existing cloud experience to help the customer to make easy connection to different clouds. And this is our actual history with Artistrade before. And we collected a lot of authors from the developers community to get many drivers we verified by the open developer communities, and all these verified drivers are published by Artistrade in the internet. Okay, finally, it's a simple conclusion, and we develop our IoT security MCUs from technology to solution, and try to help customer to adopt in different applications. So from technology, from solution to applications, to give a customer a more easy reference or guidelines to design your devices with security. Finally, this is a summary for IoT security technology developed by our Numicro family. Okay, this will cover MCU and the MPU products always in the future. Okay, yeah. So sorry, I don't know how to say. There's a bit the problem today, but I do hope I still deliver the good the good information to you. And thanks for your join. Have a nice day.
Well, no problem there, Robert. I mean, these things happen. You know, it's whenever you're doing something live, it's always a bit nerve-wracking. So I asked the attendees to post some questions. One person, it's not a question, but he did say it's difficult to find your dev boards in Europe. And he wishes that your company could do something to improve that.
Okay, yeah. Sorry. This is I got a similar argument, or we say complaint from this year. Yeah, it's due to the logistic problem and some shortage. Yeah, we will try to provide or to refill the products on our e-store to support the customer, especially in Europe, from second half this year. We are trying to solve this problem. Yeah.
Okay, we've got, supply chain problems are affecting everyone at the minute. So Andy says, why do we need an Rtos on an ARM V8M microcontroller? And he says about trust zone support.
V810. Sorry, I'm not getting.
Can you? Do you have the chat up in the interface?
Okay.
The chat window.
Okay, let me check. Okay. This is RTOS, real-time operating system. Okay. Why we need a real-time operating system? That's a good question. I think it's not related to trust zone actually, but for RTOS, this is very important, and that's why I joined this event because when you design a network connected device, you need to solve the many technical issues, including communication stack and or some related task software management. I'm sorry, it's about the application scheduling or resource management. With a RTOS, it can help you to design your device with a good software management, resource management, especially for communication stack. For example, RT3 or embed, even FreeRTOS. There are many communication stack off the shelf to be used. So you don't need to spend much time to develop the wireless protocol with security considerations. It certainly saves much time for you. I think this is a most important. I hope I answer your question. Is it?
We'll see if Andy comes back. Somebody else says, which of your dev boards do you recommend for beginners?
Yes. For IoT security, of course, I recommend a new M2354 typing. But for our other MCU, recently we also have a range of products like M4A7 IoT or I just type keywords. This is MPU.
Okay. Yeah, security. I wish we lived in a world where we didn't have to worry about security, where you could just make something that did something cool and not have to worry about the bad guys doing stuff, to you. One of the big problems, it seems to me, is you can be totally secure in your own facility, but when you go to a contract manufacturer, you're never quite sure who to trust these days. There was the famous Zombie Zero problem where the contract manufacturer actually put the malware in the product right at the manufacturing end. So do your solutions address that at all?
Yes. We do have an example before. Our customer asked us to protect their firmware and also their security identification. Actually, it's a certificate. They want us to help to inject the certificate into the chip to protect the final device. For example, like a speaker, AI speaker, or something like that. So this need a mechanism to be prepared before the chip moved to manufacturer side or DM factory to do the further assembly. We do provide such kind of service, and we are also keep collaborating with our partner, like the major programming companies, or some programming facility companies to complete our technology with their programming utility together to provide such kind of service.
Right, I think that's the way to go, actually, to, like you say, program the certificate into the microcontroller before it's sent to manufacturing.
Yep.
I'm seeing quite a bit of that. There's another company, not in your field, Lattice Semiconductor. They make FPGAs. And one of the things they can do is an FPGA has got lots and lots of different ways of programming it. And what they do is they pre-program it in the factory, their factory, and it's locked down. So the only way to reprogram it is to load a new image, but that image is loaded by the existing image. And the existing image checks that the new image has got the right authentication to come in. And it's like a chain of custody all the way down. Every time somebody else reprograms it, they have to have a new image that matches the one that's already inside. I'm not explaining it very well, but it's I'll post a link to an article about it. But I think that's the way it's got to be, where the chips are protected before they even get to the manufacturing contract manufacturer.
Yeah, I can further disclose our plan in the future. I think security is not a technology only or techniques with the chip. It's a procedure or entire process to a system product. So our future plan will be to bring more technology. I can discuss a little bit about the PUF physical unclonable function. We try to use PUF to help to create or innovate a new approach for the industry. To use this function can have a unique key without injection risk in factory side. Then with this first step, we say the root of trust, then it can further protect the firmware, software inside of the MCU. I hope I can introduce this new product in the future, yeah, because I'm planning this new product. Yeah.
Awesome. Well, maybe at the next year's RT Thread conference.
Yeah. I hope I can keep this attendance we for RT Thread event, then introduce our products from time to time. Yeah.
Awesome. Okay, well, thanks so much, Robert. And I'm so sorry about the glitch in the middle. It's disconcerting when you're presenting and something like that happens. It sort of throws you off your stride a little bit.
Okay. Yeah. I even forget to check my screen, so I didn't know the Teams was broken. So this is also my fault. But anyway, I think this is good. This is a good good presentation. It's a good showcase from my side. Thanks the invitation from Artistry, and thanks for your host. Yeah.
Oh no, thank you so much for joining us.
Yeah.
Well, theoretically, we're supposed to have a 10-minute break now, but I think we already had that break while we were waiting for everyone to rejoin us once the system went down. So I think we're just going to go straight into the second group of talks for the day. So our first speaker for the second group of talks is Brendan Slade. Brendan is the director of the NXP General Purpose MCU ecosystem team. He has more than 25 years of experience in the DSP and microcontroller industry, where he's held design, applications, and technical marketing roles, serving industrial, mobile, automotive, voice communications, and audio processing markets. I don't even want to ask what Brendan does in this. I don't want to know what you do in your spare time. So Brendan's team focuses on enablement of NXP's microcontrollers for edge processing, and that involves working with partners and NXP's internal software teams to define and deliver complementary development tool and software solutions. Brendan, the topic of your talk is introducing NXP GUI Guider and RT Thread for graphics design on IMX RT MCUs. Over to you. Take it away.
Thank you so much, Max. I just wanted to, I hope Robert will forgive me. I thought he did a great job presenting there. I just pinged something up about a company that does secure device programming for both his company and mine. So that's in the chat, that's Nuvoton. And I also wanted to ping out a link to something we just released to do with this kind of untrusted manufacturing site that would apply to anybody using RT Thread or any other Rtos or bare metal. So I just pinged that in the chat box, but I will stick to the subject at hand. I'm assuming I'm on the rough same kind of time allowance as before, and we're going to just shift along and go roll with the punches. So can you see my slides there, Max?
You can.
Okay, great. So today I'm going to talk to you about a particular application area to do with Gui Guider. We call it Gui rather than GUI, is a bit quicker to say, and how you can use that with RT Thread on graphics designs on our IMX RT crossover MCUs. So let me advance the slide. There we go. So we're going to do a very quick overview of NXP's MCU graphics strategy, so you guys know where this fits in and the option and amongst the options we have. Then I'm going to talk a bit more about what Gui Guider is and how it relates to the Lvgl open source graphics library, and then how RT Thread comes into play as an option when you're using these tools and that platform. So looking at that graphics strategy, so our approach is to provide a very broad enablement across our MCUs and MPUs, but this is focused on our MCUs. And Lvgl is highlighted here. This is the open source graphics library initiated by, or created by Gabor Kisbermozy, who's presenting tomorrow. I really encourage you to go along to that presentation if you're in any way interested in graphics. We highlight this as obviously a key part of a strategy because it's an open source based strategy. So the Lvgl library is completely open source with a very vibrant community behind it, and we developed a UI design tool, WYSIWYG design tool called Gui Guider, which complements it, and Gabor and his team have subsequently introduced a design tool for that called Squareline, which again Gabor will be presenting tomorrow. This is part of a spectrum of solutions we provide because different customers have different needs and wants. So we work with several premium suppliers in the graphics space: Embedded Wizard from Tara, Crank Amatec, Qt, Altia, and we also have other free options with Microsoft Azure and with their GUIX library, and Sega with their MWin library. MWin is a binary license, and Microsoft one is free to use with source code, but is not what you call a true open source projects like Lvgl is. So looking at the different platforms we have, I'll talk a bit more about platforms as we go, but basically the IMX RT 4 digits, so the ones that begin with a 1 and 3 following digits, that's what we call RT 4-digit crossover processors. They're general purpose M7 based, Cortex M7 based processors running up to 1 gigahertz. And then we have another family called the RT500, which is geared towards wearables primarily, but can be used in any low power application, and also has graphics acceleration. Then we have the OPC 5000 or 54,000 and 5500 series devices, which have various degrees of capabilities. The ones that have the acceleration are the RT 4-digit parts, RT500 and the OPC 54,000 series. But you can see Gui Guider is the one with the most comprehensive support, and it's not only for devices that have acceleration, but also lower resource devices as well. So if we look at the Gui Guider and what Gui Guider is, so but first we're going to talk about Lvgl again. So again, open source graphics library, very vibrant community. They're very open to contributions and suggestions, and there's a lot of evolution going on with that library. So it gives you a lot of easy to use graphical elements or widgets. and you can create great, beautiful visual effects. There's some images over on the right of some demos that they provide for free for any platform. And they also have enablement for some pretty advanced graphic animation. So you can really generate a very nice looking UI without having to go to one of those more premium solutions. And NXP has accelerators called PXP and VG Lite, and we've contributed library support for those along with other widgets that we contributed to the general community. So PXP and VG Lite provide different levels of acceleration in different things. VG Lite is vector graphics light. It's light as in compared to OpenVG. So it's a compromise between power and cost versus a full OpenG implementation, but provides a lot of important acceleration in a lot of applications. And you'll see those accelerators really come into play when you're looking at larger displays. And there's a summary here. I won't run through all the different items, but the accelerating functions that you get from using those particular hardware blocks. So Gui Guider is free to download at the link at the top of the page there. It's designed to be very user-friendly with a WYSIWYG. What you see is what you get approach, and you can easily just drag and drop widgets into the screen layout that you have. You can generate application code for all the standard tool chains that we normally support, and also we provide a series of templates for all our standard evaluation boards, so it's easy to just develop and then just drop your design onto your board and just see what it looks like. And we're continuing to add more device support as we go with each new release. So the operation of Gui Guider is pretty simple. You have your widget window on the left-hand side. We'll just fire up the old laser pointer. Easy to see what I'm talking about. So you have widgets. These are all standard Lvgl widgets. And then you have the resources. So this is the different screens that you would have. And over on the right-hand side, there's attributes. So you click on a particular widget, and then you set its attributes, its color, its behavior, its animation, and what happens when you actually perform an action on that widget. So pretty straightforward, easy to understand. And then there's an information window here which shows things like code generation progress, build progress, and so on. So pretty straightforward stuff. So Gui Guider itself is built on Electron, so it's intended so it can work with libraries other than Lvgl. I'm not going to go through all these different details, but this is the way it's constructed. And so it's built to work across different platforms and to generate different codes for different targets, and integrates on top of the Lvgl library. In terms of the Rtos support, so the earlier versions would only mention free Rtos support, but the code that's generated runs in a single thread, and this means it can be used with other Rtoses like Zephyr, which is another open source project we're very involved in, and RT-Thread, of course. And as the note shows here, there's not like a push button output to RT-Thread, but you can generate code and just drop it straight into an RT-Thread project, as we'll show at the end of the presentation. And we also provide a simulator so that you can run on a host target without having to have a board. So if you want to play around with that first and then try dropping it onto board, that's easy to do. So as I mentioned, with Gui Guider is a WYSIWYG UI design tool, and you can easily add actions and animations as you click on one of the widgets or resources. As I mentioned, you can generate code for all the standard tool chains that we normally support in our SDK and leverage the hardware that we have. So just to reiterate, it will run on Windows, Linux, or Ubuntu Linux and Mac OS as well, and supports multiple languages, English and Chinese primarily right now. And we provide several examples. There's a smart home, smart kitchen, e-bike, medical device, video demos, and we're releasing source for those as we go along. So some of those are already available, and the others we're working towards releasing the source code. So when it comes to actually doing the customization and what you do, so there's 34 widgets currently. That list is growing. We support Lvgl versions 7 and 8. And in our upcoming release in July, we'll be up at version 8.2. And then you can customize and configure the attributes of those widgets to build your design. So you don't need to really build anything from scratch because of the power of the widgets. They're all already there, provided by Lvgl. You can generate C or MicroPython source code. For this audience today, C is going to be what's most relevant, but MicroPython is also there as an option. And we have multiple fonts that have very permissive licenses, so it's easy to customize your design for your own needs. When it comes to figuring out what you're going to do when someone, say, presses a button, it's easy to insert code either in C or Python. And you just do that by just checking the customer code option and adding the code in to the box there, the black box. And it's easy to do animations. There's several, only linear is shown here, but there's bounce and ease in, ease out, and so on. So there's several ways to make buttons move onto the screen when you change screens, which is kind of the pleasing UI that we're getting more and more used to. As I mentioned earlier, there's support for many of the NXP platforms just built in, so you can easily just have all the memory setups and the right choices for acceleration if it's available on that particular MCU, and you can configure the display in case you're not using the standard one. There's 16 and 24-bit color support right now, and a wizard for creating new projects as well. When you come to actually want to generate the code, you can choose between C and MicroPython, as I mentioned, or your target on the target. In the case of the target, you just select the toolchain directly. In the case of using RT-Thread and the studio for RT-Thread, MCU Expresso is going to be your best option for the code generation, but really the code is universal, and you're just talking about different project settings that are being set up there so you can run directly into the IDEs. But MCU Expresso is using GCC as you would with RT-Thread. And there's a code viewer as well. So there's a UI definition that as you build the design, the tool is generating that in JSON format, and you can view the JSON format, and you can also view the C code generated or MicroPython code if that's what you're using. So once you've got your UI built, like this is one from our smart home demo application, you can just run it in the simulator as we show here, and then it's pretty much it is a press button selection and press button operation to just run that on the board. This image is a bit fuzzy. I don't know what happened when they captured the screen grab from this one. It's a bit blurry, so it should look exactly like it does in the image on the left. And so it's easy to see what does it really look like, what does it feel like when you start using it with the touchscreen. That's all automatic within the version that will run on the board. When you come to actually export the code, this is showing the flow with MCU Expresso IDE, where you export code and it exports into a file format, and then you can pull it into MCU Expresso IDE to build your other application around it. And I'm going to talk about RT-Thread in a moment and what you do in that case. So just summarizing everything around Lvgl and Gui Guider. So Lvgl is a very good graphics library, very optimal, especially for low resource applications, and all the enablement around that with Lvgl and the IDE and so on is all free for NXP customers to use. If you want to play around with it on a host computer, you can do that. We just Gui Guider is only for NXP silicon platforms when you go to embedded applications. We provide a great embedded graphics application development experience, very easy to use is what all our customers are telling us, and we're working hard to make it even better. And it really is very easy to put together a UI in a matter of, I would say, minutes, more than hours even, and certainly not weeks. And we're focused on optimizing this for our microcontrollers, so we're continuing to work hard on contributing to Lvgl and looking at how we can make Gui Guider enable you to optimize your design choices too. And you can keep up to date with what's going on with the Lvgl community. We also have a Gui Guider community on community.nxp.com, so you can really get involved, give feedback, and we'd love to hear from you. So in terms of roadmap, we have version 1.4 coming in July, and then beyond that we have the next minor release after that. So the kind of things we're doing in 1.4, lots of updates to the way you're interacting with widgets, adding more color depth, several new widgets that we've contributed to Lvgl, and support for the 8.1 graphics library, and more target support being added as well. So there's more resources. Here's some links. We have some pages on the NXP site telling you about Lvgl and Gui Guider and where to get. That's where you can pick up the tool itself, and the design examples for Lvgl are included in our MC Expresso SDK, and you can pick those tools up from starting from the landing page for MC Expresso. So let's move on to RT-Thread itself and look at the specifics around that. So we've been working with the RT-Thread team primarily out of our team in China, but that knowledge is spreading now for some time, and we're ramping up the focus on RT-Thread support as we see the popularity increasing rapidly. And so there's already a number of BSPs available. Our focus is around the ones that are kind of darker type here. There is support for some older LPC devices, but those aren't based on our SDK. The 824 has an SDK, but that isn't what's in this particular BSP. So all of the 54,000 series, 5500 series, and IMX-RT devices is where our focus is. And there's various different platforms from NXP and from some of our ecosystem partners. And you can see that we've been pretty active there working with RT-Thread to get these BSPs out there and accessible and easy to use for you guys. When it comes to using Gui Guider with RT-Thread, you can configure the BSP. Just follow these simple steps in the configuration, and what that will enable you to do just by selecting Lvgl for LCD and oops, there we go. And support for NXP Gui Guider. What this will do is make sure the code that's coming from Gui Guider can just be dropped straight into your project in Studio, and it's as simple as that. The code is pretty generic and portable, so it's very easy to use. And as we go forward, we're going to be supporting more devices, help working with the RT-Thread team on the BSPs, and also looking at ways that we can make the transition into RT-Thread Studio even easier. So I would encourage you to give this a go. If you have one of our boards, try it out. Even if you don't have a board, you can try the simulator and play around with it. You don't need any hardware. So we have some very exciting projects going on in relation to working with Lvgl and with RT-Thread, and really excited to see the outcome of those. So that concludes my presentation, Max. I don't know if you have any questions or anything else anyone would like to ask.
Well, I've just posted the comment. Thanks so much, Brendan. I just posted a comment saying now's a good time to ask questions. So we'll wait to see if anyone comes in with any. I'm just blown away with all the technologies today, like you say, the GUI builders and everything. You know, I come from a days where you were lucky if you could afford a toggle switch and an LED.
Yeah, I mean, I've been around a while myself too, and we have other guys in my team who specialize on graphics, so they have more history than I do of it. So, but I love to play around with these tools and just build GUIs, and you can just run them in minutes. And the way that, say, RT-Thread Studio is being done to set up and make including these things much easier is you can do so much so quickly now. It's quite amazing.
Yeah.
My first programming experience was on a mini computer and these sharp desktop machines where you had to boot them up with a cassette tape and to get some basic running, and that was.
So, you had a cassette tape?
Yeah, I learned to program computer on a Commodore VIC-20, and that was my storage media. 3.5 kbytes of RAM and a cassette drive.
Well, I think the second job in my career, we had a PDP 1123. Yeah. And you had to enter the boot sequence using toggle switches. You set a pattern and pressed enter, and another pattern and pressed enter, and that was enough to just get you to boot from the hard disk. And the hard disk was the size of a refrigerator. And it was multiple platters. So it was like a wedding cake. To remove it, you had a big glass dome that you put over it and screwed and pulled it out.
I remember seeing those.
And it was 1 megabyte, and that was for everyone in the company to share.
Yeah.
And
right.
we only had one folder, and it was the old 8.3 character naming convention. So any file that began with an M was mine, Max's. And Bill Gates famously said 64K of memory should be enough for anybody.
Yep.
Unbelievable. So
I think we had a few questions come in, right?
Marja said, I used to envy kids with games on tapes. Yeah. It's funny,
Isaac saying, finally, another person who started their career on a Commodore VIC-20. Thank you, Isaac. My brother. So I think there was a question here from Nishin asking about memory handling. So it's an interesting one, but especially depending on the devices you have, talking about what we have, right? So you have devices like RT500, which has a lot of onboard memory. It has, from memory, I think it's 5 megabytes of onboard SRAM. So to get best performance, you're going to want to put as much as that as you can into that onboard SRAM, but you can store assets in flash as well. And this is one of these optimization things I mentioned. So you can make decisions to put those assets in external flash. If you're doing something like pulling up a background image and then putting animated things on top of it, you want to potentially use off-chip memory for that, because the loading operation could be pretty quick. But it's a real, it's a bit of an art to get that absolutely optimal if you're looking for absolute best performance. And this is a kind of area where we're looking at how we can do more with Gui Guider to help people on our platforms. So that's probably the best way to try and address that. It's not a simple answer, but yes, we do try and enable those things. And then the next one is, previously LPC 1768 and 1788 were good NXP boards, I think, to teach in universities, and which one is now good? So I think that's a really good question, because you've got, depending on what you need. So if you want to look at a very entry level device, the LPC 800 series based on an M0 Plus core is very good for that. There's a low cost board called an LPC 845 Breakout, which is about $6 or $7. And they have an onboard debug probe, so they're very good for introductory level classes. If you want something in the class of a LPC 1700 series, you've got really two directions to go. You can go for the IMX RT devices that don't have any on-chip flash but run very fast and have a lot of resources. So devices like the RT1010 is the entry level for that, and then you can move up to the 1020, which has Ethernet and so on, depending on what you need. And on the flash-based devices, the Kinetis K64 is still a good platform, a little bit old, or the LPC 5500 if you want to explore security. A lot of the things that Robert mentioned in his presentations around security, those LPC 5500 series devices have those. If you want to add graphics for that too, you can do that too through the SPI interface to support the graphics. And then, yeah.
Roshan has got one. What will be the impact on the speed of the MCU?
Again, very good question. It's very application specific. So depends exactly what you're trying to do as to what it will be. The Lvgl library was written to be used on right from the lowest resource devices and upwards. So it is one of those it depends questions. So it depends on what you mean is the impact, and that's where the graphics accelerators come in on certain things, where they're much better at doing things like handling certain types of data moves and blending. And that's where, if you're blending things, that's a lot of pixel operations, and hardware accelerators typically do that stuff much better. Mm-hmm. Beside MXRT series, does NXP have any new MCU product lines? Well, the LPC 5500 series is relatively new and being added to. We are going to be having a big announcement about where we're going next at Embedded World, but I can't say any more. The answer is yes, absolutely. But I can't talk about it in this call, I'm afraid.
So the answer to the previous one was maybe, and the answer to this one is yes.
Yes, definitely. Well, I think the question is, will it impact the CPU? That's very hard to answer. It's
Well,
very
true.
dependent. But I mean, the kind of thing, I mean, you can particularly potentially pick one of the boards and then just have a play around and see what you get. You can display the frame rate that you achieve with the design. You can also use free tools in the MC Expresso IDE in order to look at the profiling and see what the loading looks like on that as well.
I think one big comment I would put in is I love GUIs, you know, and I love these tools that you can use to build them. The only thing I would say is when you're building a GUI, think about it first. Yes, you can build anything. You can do anything. You can make the most wonderful GUI. Does it make sense to the end user? You know, because the fact that you understand it implicitly and you know that you have to stand on one leg and spin around 3 times and press that button 3 times before this one becomes active is not intuitive to everybody.
Yeah, that's very true. And I think there's a real art and skill to developing in a good UI. And this is why with demo applications we've built, we tried to build them ourselves, and they look like people that, you know, engineers trying to build UIs. I mean, I'm sure there's engineers who are good at it, but especially we want to have one that looks nice, is really clean and modern looking and intuitive is a skill. And this is why we work with Gabor and the Lvgl guys. We outsource design work to them because they're very good at that. And there's other companies that do that too. You know, a lot of our partners like Crank and so on, they specialize in that kind of thing, and it's not trivial. And what we're doing with Gui Guider is giving you all the tools and the pieces to build it, but you still need to bring in that knowledge and that good thought process of exactly how somebody will use it to really get the best out of it. And one of the things, you know, along with that with the HMIs is integrating voice with the HMI, and that, you know, that's where we have our VIT library that can augment that too. And that's a really exciting new area to see how people can really use that in a device that's not cloud connected. So you're worried about security, or you don't want to be tied to a particular cloud service, you know, doing that too. So it's a very interesting area.
Yeah, I think someone just pointed out I did write an article on this sort of thing. I've written an article on just about every sort of thing. But I had a clock. It only had about 5 buttons, I think. But I lost the manual to it, and it was absolutely non-intuitive. And also it drifted in time. But I didn't know how to reset the time. You could press any buttons you wanted, nothing happened.
Yeah.
So when I woke up in the middle of the night and looked at it, I had to remember that it was like 2 minutes ahead, 3 minutes ahead, 4 minutes ahead. Eventually it was like an hour ahead. And so eventually I just threw the clock away and bought a new one. One final question before we move on. Any support for monochrome e-paper screens?
So we don't have e-paper screens directly interfaced to our EVKs, but on one of the slides I mentioned that in the upcoming release we are going to have support for 1-bit display, so monochrome basically. So yes, that is coming. So in terms of getting a design done with Gui Guider, yes, you'll be able to do that.
Awesome. Thank you so much, Robert. Oh, sorry, Brendan. Robert's on my mind at the
minute.
Right,
thank you, Max. Thanks, everyone, for your time and attention.
Thanks, Brendan. Sorry about that.
Take care. Bye-bye.
You too. Okay, for anyone who's just joined us, we had a small glitch earlier on that's thrown us behind schedule. So we're sort of racing to catch up. Please accept our apologies and bear with us here. Our next speaker is Fei Zhendong, who is HP Micro Semiconductor Application Engineer Manager. And the topic of this talk is Industrial Field Bus, Ethernet CAN FD based on high-performance RISC-V microcontrollers. So over to Fei. I tell you, some days you wonder why you got out of bed. Oh, dearie, dearie me. Okay, so Kathy says that they're working on the sound. As soon as the sound comes up, I will stop talking. Until then, I will just keep on waffling away, much like my mother. The real trick is to get us to stop talking. We were talking about virtual reality earlier on. And I ran across a company recently that is working on augmented reality and a set of glasses that literally look like the glasses I'm wearing now. And I'm going to paste this into the comment because you won't believe what I tell you. I told somebody that it was 8K glasses. And they said, what? You know, like 600 by 600 pixels. And I said, no, no, no. It's actually 8K by 6K per eye resolution. That's true 8K. So about 50 million pixels per eye. And like I say, it looks like regular glasses. Maybe 5% diminished light intensity. It uses waveguides and things. I'll post a link to my article on this so you can read up more about it. It's a company called Cura. And I, for one, cannot wait for this to come. I've been looking into augmented reality quite a lot recently. I'll send a small picture with a question, okay? That's frightening. A question about what? You can see that our team is, our crack team is working on this problem. So again, I'll just carry on until things start up and then I'll fade out. So I've been thinking about the whole reality environment. And the way I've come to think about it is that at one side of the spectrum, we have physical reality, the real world, real reality. And at the other end, we've got virtual reality, which is where everything is computer generated. So between there, we have this whole range of different realities. And what we're used to hearing is the term augmented reality, which is if this is physical reality, then augmented reality is about here. And augmented reality means taking that physical reality and augmenting it with additional information. And I think very often we think of Arnold Schwarzenegger in The Terminator from 1984, where he was a cyborg and we could see through his eyes and he was seeing textual information being superimposed on the scene. But it doesn't just have to be textual information. It can be graphical information. It could be auditory information. Oh, we can go now. Okay, I shall pick up this conversation later. Off we go.
Good morning, everyone. It's my great pleasure to have this opportunity to talk to you all on this tremendous Thread Global Tech Conference. I'm Zhen Dongfei from HP Micro Semiconductor. Today, I'd like to take a few minutes to talk about some works we have done based on our high-performance microcontrollers and Thread, especially its applications on industrial field. My subject for today named Thread-based Ethernet and CAN-FD application on 800 MHz dual-core RISC-V MCU. My presentation will include the following parts. First, I will give brief introduction of HP Micro Semiconductors, our mission and products, plus the close cooperation between HP Micro Semi and RT-Thread. Second, I would give you some idea about the core features and performance of HP Micro Ethernet controller, as well as software development kit. And then the IEEE 1588 PTP, the precise timing protocol module, which is dedicated to time management and synchronization amongst network nodes. In the meantime, I want to introduce our CAN controller, which supports both CAN 2.0 and CAN FD, and a dedicated PTPC module for CAN timestamp feature as well. Last but not least, we have implemented an Ethernet CAN gateway solution based on HP Micro MCU and RT-Thread. I want to talk about this demo, briefly including the constructions and the results. HP Micro Semiconductor is a fabless semiconductor company that founded in the year 2020. We focus on designing and manufacturing microcontrollers and microprocessors based on RISC-V core. RISC-V is an open source ISA, which is free to be used by everyone. ISA here means instruction set architecture. The RISC-V ISA, as well as its community, grows very quickly recently. It is firmly believed that the RISC-V will not only play a key role in China's semiconductor market, but also make great success in the global market. In the late 2021, we have announced our first product, the HPM6700 series, which is a dual RISC-V core microcontroller with a rich set of peripherals. The CPU can run up to 816 MHz. RT-Thread is an open source IoT Rtos. And that's why we firmly believe that there would be great potential to bring RT-Thread and our HPM6700 series microcontroller together. HP Micro and RT-Thread have become key partners right after the announcement of HPM6700. And we have released HPM6750 Lvgl Mini together. It is an evaluation kit with RTPie extension port. We have also developed RT-Thread BSP for this board. Since then, our software team have been very energetic. Please take a look at our BSP release history. You can see that our BSP is regularly updated every 2 to 4 weeks. We are continuously upgrading and adding new features. The developers can create RT-Thread new projects for our HPM6750 Lvgl Mini with RT-Thread Studio, which brings great convenience to start evaluating HPM6700 MCU and to start the RT-Thread application development. By the way, we have announced our second product, HPM6300, weeks ago. And of course, the BSP of this new device is planned. Our target is that all HP Micro evaluation kits can support RT-Thread. Before the introduction of Ethernet and CAN, I would strongly recommend that our HPM6000 series MCU is one of the best choice for users in industrial applications. Here are some key points. 1. Ultra high performance with HPM6700 CPU can run up to 816 MHz, and the HPM6300 CPU can run up to 648 MHz. It has integrated a large on-chip SRAM up to 2 MB and some very flexible memory extensions, including SDRAM, QSPI flash, serial PSRAM, and HyperRAM or HyperFlash. 2. Rich communication ports, including Ethernet controller and CAN, which I will go to the details later. Other on-chip communication peripherals including USB with high-speed PHY and numerous low-speed ports like UART, SPI, and I2C. 3. Flexible motion control unit, including high performance and flexible PWM module and encoder interface. The HPM6700 series can control 4 motors, by a single chip. There are also high-performance analog peripherals, the high-speed 12-bit ADC, as fast as 5 megasamples per second. High-resolution 16-bit ADC among the comparator and the analog comparators and the 12-bit DAC. 4. We provide easy-to-use packages. The 289 BGA with 0.8 mm pitch could support 4-layer PCB design, while the 144 L2FP package could support 2-layer PCB design. HPM 6000 series MCU also support a wide range temperature from -40 to 105 degree ambient and from -40 to 125 degree junction. Ethernet is the most classic and important industrial field bus. According to the research, the Ethernet-based protocol has more than 60% share of all industrial field buses. For example, protocols like PortFitNet, CC-Link, PowerLink, Modbus TCP, etc. Here presents you the functions and features of HP Micro Ethernet controller. There are two 1 gigabit per second Ethernet controller on HPM 6700 and one 100 megabit per second Ethernet controller on the HPM 6300. The 1 gigabit per second Ethernet port support RGMII5, and the 100 megabit per second port support RMII5. Both the HPM 6700 Ethernet controller and that of HPM 6300 support hardware IEEE 1588 PTP modules, which I will go through the details later. We provide a complete Ethernet controller driver with example codes in HPM SDK. Besides, we also integrated an Ethernet demo in the HPM 6750 EVK Mini RT-Thread BSP. We used RT-Thread ArtPi industrial I/O board to extend the Ethernet interface on our HPM 6750 EVK Mini board. The result is very good. Thanks, industrial I/O board. Also, we will release soon the HPM 6750 EVK RT-Thread BSP, which can natively support the 1 gigabit per second Ethernet. HPM 6750 EVK is a full function evaluation board, which supports one 1 gigabit per second interface and one 100 megabit per second interface. Thus, the user can develop high-performance Ethernet application on the HPM 6750 EVK. RT-Thread has a complete network framework. It has net components like LWIP, TCP/IP stack, and the net device. We have adapted the SDK Ethernet driver to these components, which helps the user to start network application development quickly. Before presenting the HP Micro Ethernet PTP module, I would give a brief introduction of the IEEE 1588 standard. It is also called the Precise Timing Protocol. It can serve to synchronize the clocks between different nodes inside a network. By the way, the network is not limited to Ethernet. It can work with all kinds of networks. This protocol defines that the nodes should negotiate master or slave roles with BMCA by themselves. BMCA here refers to the best master clock algorithms. The master and the slave can then synchronize their clocks by exchanging special frames periodically. These frames are attached with timestamps, which record the time of frame transmission or frame reception. Within a complete synchronization cycle, the slave should be able to calculate the offset from the master clock and the network transmission delay. The slave then is able to calibrate its own clock based on this information. The implementation of PTP timestamp generation has three ways. One is purely done by application software. The other is by MAC layer hardware, and the last is done by PHY layer hardware. The software timer implementation is low cost, but due to the time jitter introduced by software, accuracy may be compromised. The PHY hardware implementation is precise. but to generate timestamp on file layer need a dedicated file IC, and such IC is always high cost. The Mac layer hardware PTP block is our recommendation. It is based on hardware without software jitter, so it is more precise than software. And it is built-in HP Micro Ethernet Mac controller, which would save money from the expensive file IC. The HP Micro Ethernet controller has a dedicated PTP block, which could greatly improve the time synchronization accuracy, comparing with the software-based timestamp. PTP includes a 64-bit counter. The upper 32 bits counts in seconds, and the lower 32 bits counts in nanoseconds. The counter is tightly coupled to the Mac controller and generates an accurate timestamp when the SFD is transmitted from the Mac, or the entire packet is received by the Mac. The PTP counter is clocked by a 100 MHz PTP clock that provides 10 nanosecond resolution. The PTP block also supports clock tuning, which can adjust the PTP clock with 1/32 power of 2 step. It means that the PTP slave can tune the PTP in case that the slave clock frequency differs from the master clock frequency. The PTP block supports PPS output. Here, PPS means parse per second. Normally, PPS can be used to debug the PTP system. The PPS output parse number and the duty cycle can be programmable. On our device, the PPS could be output through EVTO signal. The EVTO means event output. The EVTO can map to I/O or can be output to other on-chip modules such as timer and PWM. The PPS also supports timestamp snapshot per event received from the EVTI event input or from other on-chip modules. Therefore, the precise clock built by PTP is not limited within the Ethernet controller, but can affect the entire chip. We have implemented our PTP application software with RT-Thread. The PTP example is already included in the BSP just released. Users can configure the system as PTP master or PTP slave. The PTP software is on the application layer and is fully benefit from the RT-Thread network frame. The data transmission and reception process are managed by the RT-Thread OS with the LWIP TCP/IP stack. We have optimized the Ethernet driver to fully adapt the HP Micro Ethernet Mac controller and its tightly coupled PTP block. Timestamp is generated directly by the PTP block. After each 1588 time synchronization cycle, the PTP slave is capable to update the PTP timer by the HPM PTP driver. In the PTP example, we have ported the PTP-D to HPM 6000 series MCU. This example is targeted to be included in the coming SDK release as well as the RT-Thread BSP. PTP-D is called PTP daemon. It is an open source implementation of IEEE 1588 standard. The PTP-D has implemented the original ordinary clock defined by IEEE 1588 version 1 and version 2, and also the BMCA as well. From the original code, the timestamp is generated by software. With our contribution, timestamp can be generated from the HPM Ethernet controller PTP block. With the demo board being connected to a PTP network, the slave can periodically sync with the master clock based on the offset and the delay measured. We have run a 10 minutes time synchronization test with two boards. One serves as the PTP master and the other serves as PTP slave. We would see that the time offset between the master clock and the slave clock is large at the beginning, but step by step, the time offset will decrease to a relatively stable level. The result shows that the master-slave clock time offset is normally within plus or minus 5 microsecond range. Now we come to CAN controllers. The CAN is called Controller Area Network. CAN bus was firstly widely used in automotive systems. Thanks to its high robustness and efficiency, CAN is also very popular as an industrial field bus. Now I'm presenting the functions and features of HP Micro CAN controller. There are 4 CAN controllers on HPM6700 and 2 on the HPM6300. The CAN controller supports both CAN 2.0 and the CAN FD. CAN 2.0 support up to 1 megabit per second baud rate, and the CAN FD baud rate can be up to 5 to 8 megabit per second. The CAN controller supports 2 CAN FD format, the Bosch CAN FD and the ISO 118.98.1/2015 CAN FD. In addition, the CAN controller supports time stamping functions, and a dedicated module PTPC is designed to provide time data to CAN controller. I will give you more details about the CAN timestamp soon. Some CAN applications also require time-stamped frames. For example, the CIA 603 specifies an AUTOSAR compliant time management for CAN networks. Time-triggered communication over CAN, which is TTCAN, is specified in ISO 119.89.4 as a higher layer protocol extension to the CAN protocol. To meet these requirements, we have designed PTPC. Here, PTPC refers to Precise Timing Protocol for CAN. The HP Micro PTPC module is designed to provide 64-bit timestamp to CAN controller, which has much higher resolution than the 16-bit required by the standard. The PTPC includes 2 timestamp modules with 64-bit counter. The upper 32-bit counter counts in seconds, and the lower 32-bit counter counts in nanoseconds. PTPC support up to 4 timestamp outputs for multiple CAN controllers on chip. The CAN module can select timestamp 0 or timestamp 1. The timestamp data can be loaded to the CAN engine with hardware data path. There is no need for software to write timestamp data. PTPC clock runs up to 100 MHz. Thus, the PTPC clock precision can be up to 10 nanoseconds. PTPC clock frequency can be fine-tuned like the Ethernet PTP module. The PTPC counter supports input capture and output compare functions as well. The PTPC counter can also take timestamped snapshots when the capture signal alters. The capture signal may come from I/O or from other on-chip modules. Additionally, the timestamp counter can be compared with a target value. In case of match, the compare event can be outputted to I/O or to other on-chip modules. These functions permit the PTPC timer to interact with on-chip or off-chip modules, and the CAN network time will not be constrained within the PTPC. We are now developing the CAN example in the RT-Thread BSP, and this example is already released in the recent BSP release. We have implemented the CAN driver porting based on RT-Thread generic device. Users can control the HP Micro CAN peripherals as a generic device in RT-Thread Rtos. The example shows how to create, how to register, how to turn on, and how to turn off a CAN device. And the user can send and receive data by simply writing and reading the CAN devices. In addition to the above functions, we have also contributed to the CAN FD function to the CAN software package. As mentioned, both Ethernet and CAN are widely used in industrial. Ethernet has wider bandwidth, up to 1 gigabit per second on the HPM6700 and up to 100 megabit per second on the HPM6300. Ethernet transmission distance is very long, while the CAN bus baud rate is relatively lower. It is 1 megabit per second for the classic CAN and 5 to 8 megabit per second for the CAN FD. And as the transmission distance increased, the baud rate will decrease. However, CAN bus networking is very simple. 2 wires is enough to connect one ECU to the CAN bus. and one CAN bus can mount multiple CAN devices. Ethernet network, on the other hand, require more complex gateways and switches. CAN is also very efficient. CAN frames are prioritized by ID so that the top priority data gets bus access immediately, without causing interruptions of other frames or CAN errors. Because both Ethernet and CAN have their own pros and constraints, it is a common scenario that the local devices jointly by CAN bus, and this local network is connected to remote host by Ethernet with an Ethernet CAN gateway. Our HPM 6000 series microcontroller offers high performance with flexible memory extension and multiple CAN or Ethernet ports. This makes them very ideal for the industrial gateway application. Thus, we have released an Ethernet CAN solution based on the HP Micro high-performance microcontroller. We are now working on software implementation for this Ethernet CAN gateway solution based on Thread and target to release the code as an example of the coming BSP release. The software can run on both HPM 6700 and the HPM 6300. It supports one Ethernet port. The port can be a 1 gigabit per second on HPM 6700 and the 100 megabyte bit per second on HPM 6300. The Ethernet part could be configured in UDP mode. In UDP mode, the gateway simply packs the CAN frames and sends them via Ethernet, or forwards the packets received from the Ethernet to CAN devices. The gateway can be configured as a TCP server mode that waits for connection requests from the remote host. Or it can also be a TCP client. Under this configuration, the gateway will periodically attempt to connect the remote host, and the gateway can support up to 4 CAN ports on HPM 6700, while two CAN ports on HPM 6300. The CAN port can also run CAN open protocol. Besides, this gateway also supports cross-network timing synchronization. The gateway can sync its local clock with the remote host by IEEE 1588, and then manage the time via the local CAN network. To sum up, we HP Micro have launched HPM 6000 series high-performance microcontrollers. They are based on high-performance RISC-V cores with flexible memory extension and a rich set of peripherals. Thread is an open source, neutral, and community-based real-time operation system. The software has extremely low resource occupancy, high reliability, and high scalability. It also has rich middle layer components and various of components which are required by all IoT devices, such as network protocols, file systems, low power management, etc. Combining Thread and our MCU is a win-win strategy. We have ported Thread and many of its components to HPM 6750 EVK Mini evaluation kit and provide BSP. User can easily start application development with Thread Studio. We are also working on bringing Thread to more HP Micro evaluation kits. The enablement of Thread on HPM 6300 is coming as well. We provide a series of example codes, such like Ethernet, CAN, and other examples for HP Micro peripherals. We have also developed an Ethernet CAN gateway demo based on the Thread, and it could be released soon. Thanks for listening to my speech. At the end, I'd like to highlight our products again. So far, we have launched 2 series of MCU. The HPM 6700 series have dual high-performance RISC-V core with CPU frequency up to 816 MHz. The HPM 6700 series has 2 MB of on-chip SRAM and a full set of peripherals. The HPM 6300 series is a single 648 MHz RISC-V core device with 800 KB on-chip SRAM and a relatively reduced peripheral set. We provide 2 BGA packages for HPM6700 series, and the HPM6300 is available in a 144-pin LQFP package and a very small 7x7 BGA packages. Please stay tuned. Visit our official website, www.hpmicro.com. Contact us at email address info@hpmicro.com. Please also follow our 2 official accounts on WeChat. Thank you. That's all for my presentation. Thank you again.
Well, thanks so much to Fei Zhendong. Once again, for anyone who has just joined us, we had a small glitch earlier on that's thrown us a little bit behind schedule. So please accept our apologies, and we hope you'll bear with us. Our next speaker is Sergio R. Rodriguez Jr. Sergio is a computer engineer with a master's in electrical engineering in control systems, which is awesome because that's what my degree was in. He's worked for a state-owned hydropower plant as an electronic engineer. He won the first place in a public contest, and also as an electrical engineering professor. And also, Sergio just became my new hero because he was the designer of the first Brazilian electronic color evaluator for roasted coffee. I don't know about you, but if I don't have a cup of coffee in the morning, the day's not worth having. Apparently, it's called ColorGap 1A, and it was produced in 2004, and it's used in quality labs. I'm not sure if that's a quality coffee lab or just quality labs generally. Anyway, Sergio is going to talk to us about RT Thread Concurrency for C++ programmers. So handing over to Sergio.
Hello friends from RT Thread community. My name is Dirceu and I work with hardware and firmware design for control systems. This short and introductory presentation is intended to dealing with some aspects of the concurrence in C++ language applied to embedded systems and data acquisition. It has 3 main purposes. 1. To present the benefits of RT Thread to professionals who already work with that language, usually on desktop world, having interest to start working with a real-time operation system. 2. To serve as a review of some useful C++ techniques and applied it to more hardware-oriented systems. In the process, some comparisons will be carried out with discussion of simple and commonly found cases in the area. 3. Finally, an opportunity to work directly with C++ in deterministic projects that use RT Thread. Okay, let's review an important concept belonging to the theme of this presentation. What's concurrence? In general, we can say that there is concurrence when at least 2 actions or threads or tasks are making progress, not necessarily simultaneously. The problems we have to solve are involved with data sharing, synchronization, and communication. In today's multi-core systems, this becomes even more complicated, because it's not just about moving between one process to another, but actually dealing with things happening at the same time. For example, how to ensure that threads are working with the same data stored in cache memory. Fortunately, as well we'll see, an operation system like RT Thread provides tools to make the developer's life easier. Let's present a simple example to compare sequential systems with concurrent ones. The three-stage problem is normally given in optimization theory, but we can treat it as a concurrency problem as well. It's asked how long it will take in order to fry 3 sticks using a frying pan or CPU here that only holds 2 sticks at a time. I required 5 minutes in order to prepare each side. The most obvious solution considered here as the sequential one is to divide the action in 4 tasks, as shown. Note that, as in a real operation system, the tasks have associated states, something as running, waiting, and finishing. First, fry the sides of 2 sticks, do the same thing with the other 2 sides in the next 5 minutes, remove them, and finally fry only 1 stick in the following 10 minutes. So, the total time is 20 minutes. Of course, in this solution we don't use the frying pan efficiently. At the end, the food remains cold. Our so-called concurrent solution involves breaking down task 2 into 2 other subtasks and switching between them in a proper time. It involves removing a stick with a side already done by the other. The total time is reduced to 15 minutes. We agree that is not a very practical action, but it serves to show the concept of stopping one task in the middle and switching to another. Indeed, a context switching. Let's talk a little bit about parallelism. Since the advent of multi-core systems, the true parallelism has been a reality in our daily lives. This is a kind of multiple instruction and multiple data. Parallelism can also occur in the instruction level of a single processor. For example, the single instruction multiple data on ARM processors, such as multiply and accumulate operations typical from the SP field. In parallel systems, the actions are performed really at the same time. For example, in the previous problem, using 2 frying pans, the total time will be just at 10 minutes. I really like to use the right side figure in order to illustrate the 3 processing ways: sequential, concurrent, and parallel. 2011 year brings us the threading support on C++ through the standard template library, STL. Before, that could be accomplished only using specific external libraries. In Unix, besides there was multiprocessing from the beginning, there was no current concept of threads as lightweight process, having less overhead. The famous Boost library uses POSIX threads, or pthreads, for its implementation. In my career, I have had contact with most of these technologies. For example, in the Windows operating systems before Win API, there was the so-called terminate and stay resident program. Since that time, multi-threading support in C++ has greatly increased as versions have been published. Currently, many compilers don't support all the latest features. For example, only GCC 11 supports C++ 20 semaphores. For that reason, this presentation will be based exclusively on C++ 11, the version on that could be better supported on some other systems. It's worth remembering that determinism and real-time behavior are dependent on the facilities offered by the operation system. Since C++ is just a language making use of that features according to the implementation. But we have to realize that C++ is growing in embedded systems, mainly due to current requirements, for example, in image processing and artificial intelligence. As our time is short, we will make a brief review that will be useful not only for who currently programming in C++, but also for one intending to use it with RT-thread, for example. The class std thread based on Boost thread represents a single thread of execution. Threads allow multiple functions to execute concurrently. It should be noted that, unlike what happens in RT-thread, we don't have control over time slice or thread priorities here. On the right side, there is an example creating a simple task that takes a parameter. On the left, a usage with a C++ class. Classically, a thread function is implemented as a static function on class, but as shown, it's also possible to do it with a class method through the proper constructor. You can use the same code on multiple architectures, including Windows, where an implementation using Win API takes place. One of the most basic primitives for exclusive access is the mutex. Here in its version, SCG mutex implements the lock-unlock semantics. Used alone, the mutex has limited application. For example, consider the code below where the idea is to share a buffer between two threads, one producing a set of images and another consuming it. It wouldn't be recommended to share data in this way between a main thread and an interrupt service routine, due to a non-deterministic locking interval. Also, this is not an efficient solution. Besides the mutual exclusion, we are doing a pooling after all. The execution code entering at the critical section just to realize out that buffer is full or empty. There are two important classes that can be used with Mutex, which we will make extensive use: LockGuard and UniqueLock. It implements the resource acquisition is initialization technique, meaning the mutex is acquired in the constructor and released in the destructor. The rationale behind them is very simple. For example, these objects can be placed inside loops, being created again in each iteration. The condition variable is implemented in most high-side architectures. Like the previous classes, it also depends on a mutex. But now we have a notification and waiting system without consuming processor time while waiting for a given condition to occur. In other words, no pooling. The thread blocks in wait for, or wait until methods releases the mutex while waiting for the condition. On the other side, the methods notify1, notify all allow to wake up the waiting threads. Then the method wait returns and the mutex is atomically reacquired and stays so until the end of the block or when intentionally released. LockGuard can be used with notify methods, but not with wait ones. This makes sense because LockGuard doesn't perform the unlocking needed by wait. The companion example is an improvement regarding the previous one. Here, a high-speed serial port decoder, not the checking for a condition after the return of wait method. This deals with a spurious wake-up problem. What's the spurious wake-up? It happens when a thread wakes up from waiting for a condition variable only to find that the condition it was waiting for has not been satisfied. Could be happen due to two reasons. The condition variable was notified and, when the waiting thread finally wakes up, another thread ran and changed that condition. Or simply a waking up without a real notification at all. It's a good practice to implement that checking in a loop. It has an additional advantage. Also deals with the lost wake up. We know a notification works like a pulsed signal. In this case, the calling of wait could be done after the notify execution. In other words, the notification is lost. Next, an example using two condition variables around on mutex. One of them to wait notify the buffer not empty situation, and another similar to handle buffer not full. The producer thread waits for enough space in the bounded buffer. When this happens, it places an item in the buffer and notifies a potential blocked consumer thread, waiting for a non-empty buffer event. A similar situation occurs with the other thread, which wakes up a producer thread blocked due to a foul buffer. Note that handling for spurious wake up around each wait. Semaphores are part of RT-Thread Rtos. But as I already mentioned, C++20 semaphores are only available in GCC 11, but that doesn't mean that this important synchronization mechanism cannot be built with other classes already presented. Here I show a simple class implementing semaphores, very well known online. Semaphores are useful when there is a certain amount of resources of the same type, which can be reserved by threads for processing. The idea is to adjust the semaphore value according to the number of the available resources. A thread acquiring a semaphore weight decrements this value atomically. If it reaches 0, the corresponding thread will be blocked. After a thread uses a resource, it can release its signal. So the associated value ends up incremented, and a waiting thread will wake up. Note the need for additional mutex in this example in order to provide exclusive access to the resources. Remember that in the condition variable case, the mutex is automatically reacquired when wait returns. Finally, here the threads are created using lambda functions rather than the traditional way. Waiting for more than one event using a condition variable is an easy task. It's enough to create notifications for each event and increase the checking list in the while loop associated with the wait method. These notifications can be spread for the whole code. In the present example at TCP client, an event is also provided in order to inform the thread run to terminate, stop. This type of mechanism is useful to have control of thread lifetime. The following is an example of timer to illustrate waiting on a condition variable using a timeout. We are helped here by the chrono library. Different of wait for the variant wait until distinguishes between spurious wake up and timeout occurrence. Here, the thread run works periodically, but it can also listen to a stop event. The key point here is the comparison with the enumeration stdcv status timeout. Next, other example regarding wait until. The task ECK waits for 3 conditions or events: an ECK packet arrival, an ECK timeout, and the task termination. Rto thread. It's not an older Rtos. It's not only a real-time kernel, but also has a rich middle-tier component, suitable for several architectures, including non-microcontrollers. Added support on asymmetrical and symmetrical multi-core systems. It's open source, written in C, such as Linux. Nano version for constrained devices. A complete set of development tools like RT-Thread Studio. The great news for us is that RT-Thread also supports the C++ threading system and the pthreads, or POSIX threads, as well. See this figure of the RT-Thread Studio software, showing an example of configuration. Thus, it's also possible to write the C++ applications for RT-Thread and take advantage of material presented on first part. Of course, the most direct and useful way to make concurrency on RT-Thread is using the tools provided by the kernel. There are plenty of support for managing time, memory, interrupts, thread communication, and so on. Next, we introduce the functions related to thread synchronization, namely Mutex, Semaphore, and event. Now let's talk about the features of the threading system. The biggest difference between C++ threads is that here it's possible to set priorities for individual threads. RT-Thread offers up to 2056 priorities, where 0 is the highest one. It should be noted that the thread with the highest priority is the one that runs, unless it's blocked. When more than one thread has the same priority, a round-robin mechanism is performed. It's also possible to specify the time slice of each thread, and when this time runs out, a context switch is performed to another thread of equal priority. The thread priority associated with the main function can be changed too. The figure shows the different states of the threads as well as some control functions. Several RT-thread kernel system objects can be created in two ways, dynamic and static. The current example shows how to create a thread dynamically with a parameter passed for it. So, using RT-thread create function, the thread handle and stack space are dynamically allocated from the system stack. On the other hand, using RT-thread init function, the thread handle and stack space are statically allocated from the user code. Mutex is a binary semaphore. Unlike Semaphore, it can only be released by the thread holding it. The mutex is immune to priority inversion problem. This situation can occur when a low priority thread is using a resource and a high priority thread is blocked because it also wants to use that resource. An intermediate priority thread that has nothing to do with the resource ends up running wrongly. The order of the NQE blocked threads can be respect the timeline or the thread priorities. Finally, the mutex supports recursive access, where the thread can acquire the mutex multiple times without being suspended. The mutex take and mutex release functions are equivalent to std mutex wait and notify from C++. The following is a previous example of C++ converted for use with RT-thread mutex. A timeout between 0 and infinite can be provided when calling the take function. The return value can be used to identify the success, timeout, or error. A 0 timeout is equivalent to a peak function named try_take. Event set is order of the mechanisms or synchronization between threads, event send and event receive. A thread is blocked waiting for one or more events to be received. We had reached a similar effect on C++ using a condition variable. Do you remember? An event set can contain multiple events. There is no data transfer involved. Sending the same event to the thread multiple times is equivalent to sending only once. Events can be combined by the logical and logical OR operation, meaning that the arrival of an event would be enough to wake up a thread or the occurrence of all of them. A 0 timeout is possible too. The companion code shows a synchronization between two threads, task LED and task button. The first button press causes LED start blinking and the next turn it off. Differently, on C++11, the RT thread implements semaphores. Do you remember the previously presented class semaphore having the methods wait and signal? The behavior is very similar. On RT thread, that effect is obtained through the send take and send release. Such as other synchronization mechanisms, a timeout for waiting can be specified too. Okay, that's all, folks. So, good luck using RT-thread and C++ in your next design. Thanks for watching.
Well, thanks very much. Andre posted a comment, a one-word comment saying, "Dear CU." So either it means he's really happy to see that Dear CU is available in the comments for questions and answers, or he's complaining about my pronunciation. My Portuguese is not as good as it once was, but pronouncing foreign terms is not as easy as you might think. And as an example, I'm just posting one in here. The classic English source. How would you pronounce that, Andre? Anyway, so as Kathy posted, Desu is not joining us by video, but he is joining us in the chat. So if you've got anything to ask about his presentation, then this would be a really good time to do so. And he's also posted in a circular queue scenario the additional mutex on previous class semaphores not necessary. Okay, and then Dercio, there's one here from. Oh, that's great. Dercio's given us his email address so that if you've got any questions, you can pass them there. And Dercio, do you see this question here from Numo Felicio? There was a time that the thought of launching a thread to run timer tasks would make you fired. Actually, there's a time when a lot of things would get you fired. I've got a question for you programmers. When you're typing your code, I'm a hardware design engineer by trade, so software I'm a bit flaky at. When you're typing in your code, do you use the tab key or do you use spaces? So if you're doing the other thing is, how many spaces do you use to indent your code? Do you use 2 spaces or 4 spaces or 6 spaces? And again, do you use the tab key or do you actually press the space key over and over again? Keep on, if you've got any more questions for Dercio, keep on posting them in here. And Dercio says tab. There was a survey. Yeah, you update your editor. So, all right. So I use 4 spaces myself. And here we say you update your editor, so the tab is equivalent to 4 spaces. The only problem with that is if you take that source file and give it to somebody else whose editor has not got the tab set up to 4 spaces, things can go all over the place. And so everyone seems to be really keen on tabs here, but there was an article published a couple of years ago that showed that they surveyed something like 2,000 programmers, and on average, the ones who use spaces as opposed to tabs earned about 10% more. So, doesn't everyone know? I love Notepad++. I was only just introduced to it a few weeks ago, and and it's all right. So the name of the source in England, that let me post that again for you. This is the one when in America it seems like they don't know when to stop saying it. They keep on going Worcestershire, but in fact in England we just say Worcester sauce. So once again, pronouncing foreign terms is not always as easy as you might think. Okay, so now it's time for our second giveaway for today. And I'm delighted to tell you that Kathy's told me that the winner is Chloe Lu. And also Kathy's just posted a link to the next giveaway. And will be, this is for the development boards, of course. And we'll be announcing the winner of that at the end of the next session of 4 talks. And don't forget that we're going to be having a super dip at the end of the conference tomorrow, where the lucky winner will be presented with 1 each of all of the development boards. Now, I was going to leap straight into the next session of talks because we are running a bit behind. But I've been told that people are asking, they want to know more about what I was going to say about the virtual reality stuff. So what I was saying there is that at the one side of the spectrum, we got physical reality, which is the real world. At the other side of the spectrum, we've got virtual reality, which is all computer generated. And you've probably heard the term augmented reality, which is sort of close to physical reality. We take the physical reality and we augment it with some sort of information. And some people think of that as being like the goggles that we were talking about. And I really can't wait to see these goggles from Cura, the AR glasses. True 8K, 8K by 6K resolution for each eye, 50 million pixels per eye. That's going to be mind-blowing. And we don't just have to augment the scene with textual information. It could be graphical information and everything. Augmented reality is only a piece of the puzzle. There's another type called diminished reality, DR, and that's where we subtract things from the scene. So in the same way that I said that augmented reality, it's not just text and graphics, it could also be smells or sounds. Diminished reality, we take things away from the scene. So that could be if you're in a conversation in a crowded room, it could be fading down all the other voices apart from the person you're talking to. Or I once went to see Pink Floyd live in 1975, the Dark Side of the Moon tour. It was an open air field with 400,000 people. And when you went to get a snack from the vendors at the side of the field and tried to come back to find your friends, it was a sea of colour and your mind was overloaded and you could not recognise your friends. And I can imagine that wearing an augmented reality headset using diminished reality where maybe all the colour faded out and it was only, so everything was black and white apart from your group of friends who are in colour. So all of this together is mixed reality. Another aspect of that is called augmented virtuality. And this is where we have the virtual reality, and then we augment it with pieces from the real world, like a person or an object. And there's one more that I fear might be heading our way in the future, and it's called hyper reality. And I've just posted a link to that. You can watch it later, but it's a mock-up of a possible future where somebody's wearing AR goggles and is being overwhelmed with information. How's the ABBA VR concert in London? I've not been, I'm afraid to say. But I did see the Police live in Leeds once, many years ago before they broke up and Sting went independent. And I saw Supertramp. That was a good one. Okay, so I think we're going to get back. Oh, I will tell you one thing about the Supertramp concert. I was going down with a friend, a young lady friend, as it happens, and her mother. There was a special offer with British Rail, the train service, and it involved cornflakes, the boxes of cornflakes. And if you collected the strip on the top of the box of cornflakes, and you collected about 100 of them, you got 2 first-class return tickets to London. And my friend's mother had been collecting these for years, and had the full complement. So we got the 2 first-class seats. And this was when I was about 20 years old, and we were all very long-haired and hippie and everything. And when we got on the first-class train, the other passengers were not happy, and there was a lot of muttering. And when the ticket collector came, they all went into a huddle and muttered about us. And then the ticket collector came down to us and said, "Can I see your tickets?" And we proudly showed our first-class tickets. And it was like, "That'll do nicely. Thank you so much." And everyone else in the carriage was very disgruntled about us. Okay. Well, I don't think we're going to go have a break. Your break was me talking, I'm afraid. So we're going to start our final group of presentations. And the first speaker is Leon. Leon's a PhD student in instrumentation science. He's the founder of PikaScript Python editor, maintainer of the RT Thread package community, In 2021, he launched the PikaScript ultra lightweight Python engine project, which has been able to run on dozens of MCUs and was awarded the 2021 Gui Most Valuable Open Source Project. So the title of this talk is PikaScript, an ultra lightweight Python engine running under RT Thread. So I'm going to hand this over to Leon.
Hello, every expert. The convenient and fast solution. Hello, every expert and developer. It's an honor to be here at the RT Thread Global Technical Conference. And I'm sharing today is PikaScript, an ultra-lightweight embedded Python engine on RT Thread. In embedded applications such as IoT and smart terminals, script development is a convenient and fast solution. When it comes to the development of embedded scripting languages, the first thing that comes to mind is MicroPython. MicroPython allows engineers to use the scripting language Python for MCU development, which greatly reduces the development time spent. However, there are not many development boards that can be used directly in the development of MicroPython. It is a huge project and a long time to port MicroPython for the MCU without ready-made MicroPython firmware. And MicroPython needs at least 190 KB of ROM space and at least 20 KB of RAM space, which will take up more resources when some drivers need to be supported. This makes many mainstream microcontrollers, such as the Blue Pill, not capable of running MicroPython, which result in high hardware costs. So, what is PikaScript? What changes can PikaScript bring? First, PikaScript is an ultra-lightweight Python interpreter that can run on 32 KB of flash and only 4 KB of RAM. PikaScript is built completely from scratch. It is not a branch from MicroPython or CPython, and is designed entirely for resource-constrained microcontroller systems. PikaScript is an open-source project that uses the MIT protocol, which is a very friendly protocol for commercial usage. It allows secondary distribution and does not mandate that PikaScript-based projects are also open source. The hit of this open source project is currently growing at a high rate. PikaScript has an officially maintained evaluation board. This development board is based on Stm32 Qbi with only 64 KB flash and 8 KB RAM. It can not only run the PikaScript kernel, but also install the complete peripheral driver packages. This level of the microcontroller is unthinkable for MicroPython. PikaScript is an open and cross-platform Python engine that was designed to be cross-platform, so it is very easy to port a new microcontroller yourself. There are already more than 20 microcontroller platforms that can run PikaScript. and about 40% of them are contributed by the developer community. We can compare the main platform Stm32 Qbi on which PikaScript can run, and the main platform Stm32 F4 on which MicroPython can run. And we can see that the difference in resource usage is very obvious. PikaScript can run on a platform with more than 80% lower resources than MicroPython. This means that PikaScript can bring more than 80% hardware cost savings to developers. Or relatively, more users' programs can be run on the hardware, and PikaScript can be compatible with already existing projects very easily. PikaScript supports the basic part of the Python 3 standard syntax, which already covers most of the syntax that can be used in most cases. More syntax details can be found in the GitHub README documentation, and PikaScript will continue to support more syntax while maintaining a very flexible and configurable feature set. Unlike MicroPython, which has to be developed on in Linux, PikaScript provides good support for both Linux and Windows environments, which means that Windows developers don't have to spend extra time to get familiar with Linux, and can use rich Windows development IDE such as Kill, IAR, Thread Studio. PikaScript has been widely covered by many tech communities, including CNX Soft, and there are several review videos on YouTube. PikaScript has also caused a firestorm of discussion on Reddit. PikaScript is deeply adapted for Thread. It can run on Thread through the software package and support all Thread BSP. PikaScript supports part of Thread's peripheral framework and can drive Thread's peripherals directly without any porting. Developing C modules on MicroPython is a lot of work and difficult. PikaScript provides a very convenient tool for developing C modules. Just declare the API for the C module in Python syntax, and the pre-compiler provided by PikaScript will automatically generate the binding code to bind your already written C program to Python. For easier deployment and resource saving, PikaScript provides tools to compile Python scripts in advance in addition to the regular mode of interpreted runtime, and the ability to package multiple Python files into a single binary, which means that Python scripts can be run using the PikaScript engine without even needing a file system. PikaScript provides a pip-like module manager that uses the same syntax as pip, enabling easy installation of modules and updates to modules. This package manager is completely open, and currently about 40% of all modules are contributed by third-party developers. To solve the problem of device driver API fragmentation in MicroPython, PikaScript provides a set of standard device drivers. This standard driver can ensure the cross-platform capability of Python drivers, and a set of code can run on all platforms. Here are some demos, all running on the very resource-compact Stm32 Qbi platform. The first demo is the GPIO Blink. The second demo is the reading and printing of data from the serial port. The following demo shows the promise of PikaScript for GUI applications. This demo is adapted to the ARM 2D graphics engine and can be run interactively to control the graphical interface. PikaScript uses very few resources to make the microcontroller support the GUI design for Python programming. If you want to learn more about PikaScript, you can find the project repository by searching PikaScript on GitHub. And if you have any questions, you can get in touch with us and get help by submitting an issue. Next, I will install the PikaScript package using Thread Studio, and then demonstrate how easy it is to use PikaScript on Thread. First, open the settings screen, find the installation screen of the package. Then find the programming language grouping PikaScript and click Install. Then wait for the PikaScript installation to complete. Here I have installed it once beforehand to save time. Then open the emulation run, and you can see Thread running normally. Then type Pika in the window to be able to run the default startup script of PikaScript, and enter the interactive run. We can perform a simple test in an interactive run.
Next, I will show you where the Python script that start is located. We will start by exiting debugging. Then open package. Then open PikaScript. Then open min.py. For editing purpose, we will use VS Code to open it. And after opening min.py, we will be able to see the script we ran earlier. We imported a standard library, a special library for Thread, and then printed hello PikaScript 3 times in a for loop, as well as the current memory usage. Here we can simply write some more scripts to test. For example, define a function, and then call the function. After writing it, we run the pre-compiler provided by PikaScript. After running the pre-compiler, the Python files are loaded into the C firmware. Then we just compile and run it. Then type Pika to start min.py. As you can see, hello in test can be printed out, and the functions we defined in min.py can be run normally. Also, we can run test directly in the terminal, which means Pika supports defining functions in min.py and calling them in the terminal. In the next part, we will briefly demonstrate how to make a C module. Making a C module is to connect Python and C, which is quite troublesome in MicroPython. But PikaScript provides tools to make C modules quickly. A C module in PikaScript is a single file, testmodule.py. Py means it is an interface file. And then we get the basic object from PikaObject. Then we create the test class. We define an add method so that it has input and output. A C module interface is written now. because it needs to be connected to C. So you need to use Python's type annotations to mark up the input and output types. Then we import the module in min.py and run the pre-compiler in the terminal. By this time, the C module will have been loaded into firmware. Next, we need to implement the functions defined by the interface in C. The pre-compiler have already generated the declaration of the implementation function for us automatically. Next, we write the implementation function in min.c. With just one single line, the C module is created. Then we can refresh and recompile. We also need to introduce the PicaScript header file. Then we go to run. At this point, we can create the object directly from the C module. We need to go to the interactive run of Pica first, and then create the object from the C module. The C module is already connected to the return A plus B inside the C module at this point. Isn't it very simple? So it's easy to use PicaScript to make a C module yourself.
Next, we can watch a third-party review video on YouTube to learn more about what the community think about PicaScript.
Olá a todos! Neste vídeo, você vai aprender a gravar uma imagem Python num Stm32, mais precisamente o seu clone chinês, com memória de programa de 64 KB. No vídeo passado, tentei flechar o PicaScript na Bluepill e no W806. Na Bluepill, tentamos usar o template fornecido do site do PicaScript usando o ArmQ. Também baixamos um repositório de demonstração para Bluepill no Platform.io. E não conseguimos compilar um executável em nenhum dos dois casos. Depois, tentei compilar um executável do PicaScript para o W806. Também sem sucesso. Ao postar o vídeo, recebi muitos comentários do Sr. Ling, a quem agradeço pelas informações, dizendo que no repositório template para Bluepill, o compilador do ArmQ deve ter licença Community, no mínimo. Isto se dá porque o compilador ArmQ compila executáveis limitados por 32 KB de tamanho na versão Lite, que era a que eu estava usando na ocasião. Eu perguntei se existia algum makefile para compilação usando o ArmGCC, e, ao que parece, ainda não existe, porque fui recomendado a utilizar a demonstração do Platform.io. Apesar de eu já ter tentado compilar o PicaScript neste repositório do Platform.io, existe um driver para o Stm32 que é dispensável para a execução do PicaScript no microcontrolador, e que, se removido, faz com que o executável tenha menos de 64 KB de espaço. Estamos aqui com o repositório original de demonstração do PicaScript para a Bluepill do Platform.io. A primeira coisa que vamos fazer é alterar o script linker, para reduzirmos o tamanho da memória flash disponível para o executável para 64 KB. Este passo eu já fiz no vídeo anterior, mas estou repetindo aqui caso não tenha assistido. A segunda coisa que vamos fazer é retirar o módulo Stm32 do main.py. Basta comentar a linha do módulo e recompilar o main.c usando o executável que veio pronto no repositório. terceira alteração é necessária apenas se você, assim como eu, está usando um clone chinês de STM32, ao invés do chip ARM original. Basta acrescentar esta linha no arquivo de configuração de projeto do Platform I/O. Eu também fiz esse passo no vídeo anterior. Estou repetindo apenas caso não tenha visto. Agora estamos prontos para compilarmos o projeto de demonstração do PicaScript adaptado para a placa que estamos usando. Repare que a compilação foi bem sucedida. Conectei o ST-Link V2 na BluePill. Veja que ela está com sua memória apagada. Vamos fazer o flash do projeto pelo Platform I/O. O procedimento de flash falhou porque eu me esqueci de desconectar a placa do ST-Link Utility. Desconectando e flashando novamente, repare que agora o procedimento de flash foi bem sucedido. Isso significa que já podemos usar o Python na placa. Para acessarmos o terminal REPL do PicaScript, vamos abrir o arquivo main para ver qual porta UART foi inicializada. Como podemos ver, a porta UART número 1 é inicializada quando a placa é ligada. Acessando a função, podemos ver as configurações de UART utilizadas. Vamos abrir o PUT para acessarmos a porta serial de acordo com esta ligação a um conversor USB para TTL externo, ligados aos pinos da porta UART 1, que é exatamente o que eu tenho em minha mesa. No meu PUT, já deixei um profile gravado com as configurações que já mencionei. Também aumentei o tamanho e troquei a fonte das letras para facilitar a visualização. Com o terminal serial inicializado, vamos resetar a placa pressionando o botão de reset. E aí está, finalmente funcionando na STM32. Segue agora uma breve demonstração. Não entendi exatamente o porquê de uma declaração de função não ter funcionado, mas outros comandos de sintaxe Python funcionam. Gostaria de agradecer mais uma vez ao Lvgl pelas informações. Olá a todos! Recentemente, fiz um vídeo flashando o PicaScript numa BluePill com apenas 64 KB de memória flash. Manifestei meu interesse em flashar também no microcontrolador Winner Micro, devido à sua documentação fraca, e também devido à falta de uma imagem MicroPython ao microcontrolador, aliada a uma RAW também fraca, que fazem com que o PicaScript seja uma alternativa que viabilize o uso desses microcontroladores, de forma que eles se tornem mais populares. Percebi que o W806 possui suporte total ao PicaScript. Em vídeos anteriores aqui no canal, eu até baixei o template do W806, mas não sabia onde encontrar a SDK para compilar o arquivo de projeto que vinha no repositório. Até que o Sr. Lvgl, mais uma vez, me ajudou recomendando procurar o arquivo Leia-me do W801. E lá, eu vi que realmente existia uma IDE para essa família de microcontroladores. A IDE se chama CDK e está disponível no site da Thread Semicondutores. É o mesmo site onde você pode baixar a toolchain GNU para a arquitetura 6K. Que é a dessa família de microcontroladores. Eu já falei sobre esse assunto nos vídeos que eu fiz no canal sobre esses microcontroladores, mas eu realmente não sabia que a Thread disponibilizava uma IDE para isso. Uma notícia boa é que ela disponibiliza também um core para o QEMU, debugger e outras ferramentas de desenvolvimento. A ruim é que, infelizmente, a IDE deles, chamada CDK, serve apenas para Windows. Eu até tentei instalar numa máquina Linux usando o Wine, mas sem sucesso. Estamos aqui no site da Thread e vamos fazer o download da IDE para compilarmos o PicaScript no W806. Infelizmente, precisamos nos cadastrar para fazermos o download. Feito o download, basta instalar a IDE no computador. Como a IDE já está instalada no meu computador, vou pular esse passo. Feita a instalação da IDE, vamos baixar o template do PicaScript para o W806. Uma vez baixada a IDE e o template do PicaScript para o W806, vamos entrar agora na raiz do repositório template do PicaScript para o W806. Vamos abrir a IDE no nosso computador. procurar o arquivo de projeto que encontra-se na raiz do nosso repositório de template e abrir com nossa IDE. Para obtermos a imagem do PicaScript, basta compilar o projeto na IDE, clicando no botão de compilar. A imagem se encontra na pasta Output do template. Para fazer o flash, fiz um pequeno makefile chamando o programador, que também vem junto no template, na pasta Tools. Com a placa de desenvolvimento do W806 ligada ao computador através do conector USB, vamos realizar o procedimento de flash. Neste momento, devemos pressionar o botão de reset no microcontrolador. Vou deixar indicado aqui no vídeo de qual botão estou falando. Com a gravação concluída, vamos agora verificar se o Python está funcionando na placa. Vamos acessar o microcontrolador via o ART através do PUT. Eu aproveitei o arquivo de configuração da Bluepill do último vídeo e fiz um outro igualzinho para o W806, trocando apenas a porta serial do Windows, que era diferente. Dando reset na placa, o microcontrolador para de imprimir os caracteres C e passa a realizar o boot. E, como podemos ver, temos um Hello World. Para acessarmos o terminal REPL do PicaScript em Python, vamos alterar o programa de boot main.py. Percebemos que o main.py possui um loop, onde ele liga e desliga um pino na placa. Vamos comentar esse loop para ele terminar a sua execução até o print do Hello World. Vamos usar o compilador do main.py para transformá-lo em C e, em seguida, compilarmos com a IDE novamente. Feita a compilação do novo arquivo main.py, estamos aqui na IDE para compilarmos novamente o projeto. Fiz a limpeza do projeto para que a IDE apague os arquivos de saída e seus objetos, e partiremos para a compilação. Feita a compilação, estamos aqui novamente na pasta de saída para fazermos o flash. O procedimento é idêntico ao que fizemos da última vez. Feito o flash, vamos acessar novamente o microcontrolador via o ART através do PUT. E aqui podemos ver que depois do Hello World, a placa entra em modo REPL. Vamos fazer um pequeno teste. Aparentemente, está tudo funcionando corretamente. Vamos definir uma breve função. E aqui tivemos um problema na declaração de funções, mas as funcionalidades básicas do Python estão funcionando. Gostaria de agradecer a atenção de todos e até a próxima.
Well, thanks to Leon. I was a bit surprised by the ending there. It took me by surprise. Okay, our next speaker is Dr. Leo Chewei. Dr. Leo holds a bachelor's degree in electrical and electronics engineering, a master's degree in electrical engineering, and a PhD in electrical engineering specializing in micromechanical systems, or MEMS, from the University Technology Malaysia. Dr. Leo has got more than 20 years experience in engineering software development, consultation, training, and industrial automation. And the title of Dr. Leo's presentation is Using RT Thread for Industrial IoT. So welcome, Dr. Leo, and over to you.
Hi. Yeah, good day to everyone. Yeah, no matter what is your time zone. I'm from Malaysia, so actually it's kind of 3 a.m. now. So I have 30 minutes. So let me just share my screen. Yeah, I hope you can see my screen.
We're not seeing it as full screen presentation.
Yeah, let me expand. Is it full screen now?
Yeah, that's perfect.
Yeah, okay. So today I'm gonna share about using RT-Thread for industrial IoT, or in short form, IIoT. So this is what I'm gonna show today. Yeah, I have one of the board that actually support RT-Thread. It's called AtPi that you can see here. And as you can see on the screen, when it is actually booted on the terminal that I'm connected to the IDE, I can see the AtPi RT-Thread system. You can see Thread operating system 4.03. So in industrial IoT, very often we want to actually connect industrial device rather than the hobbyist device or simple sensor through the IoT. So let me just illustrate using a diagram, right? If you can see here, an industrial IoT, or in the old name, I would say it is called SCADA, right? That's why I put the name SCADA here, supervisory control and data acquisitions. In a typical industrial environment, you actually have many machines. So here I illustrate by having machine 1, machine 2, and another injection molding machine. Maybe you actually have a PLC, programmable logic controller, connecting to many sensors. And this PLC will actually send the data through network, either wire or wireless, to a client on the same network, or actually go through what we call a gateway that eventually go to the local area networks of the companies. And this will actually connect all the way up to other clients. Those are maybe like another plant, maybe the production manager that is not sitting beside the machine, right? So this is typically what the inside the industry have. Nowadays, when we call about IoT, like Internet of Things, from the central database called DB, it probably can be a cloud system. It probably can be an on-prem system that actually connect to the internet. And from here, we actually can remote access from through the internet. So let's narrow down to here. So there are many things that actually the RT-Thread can be used in the industrial IoT. For example, I put it as a gateway. Today, my topic is using the board as a gateway. So for a gateway, typically, as you can see here, it just needs some connectivity to the network or some protocol that is supported by the sensor. For example, there are sensors that is using Modbus RTU, RS485. There are sensors those are sensors that are actually using RS232 or maybe just voltage. And a board like this actually can collect all this data, or it can actually also become a full gateway that connect to the PLC. Okay, this is the background. So I want to share about my exploration using RT-Thread. So first of all, if you want to use the RT-Thread on the board that I have, we install the RT-Thread SDK, IDE, and from there we have the SDK manager, and we actually can select my board. The board that I actually having here is this. So select it, and then I will actually see it. It's a Stm32 has 750 base, right? And then, of course, the first thing that we want to know is whether it works or not. LED blinking is always the first thing, right? This is what I do. Like typically, we do a LED blinking, and then you will see the board blinking. Yeah, the LED. This is LED. Okay, so once it's actually done, we can actually see how we actually make it in practice. So in fact, for this AtPi board, right, there is actually a GitHub that basically I follow to learn out my way of using RT-Thread. Okay, so I actually just give some visual diagram before I go to the demo. right? This is actually the starting page on the GitHub. Here they even explain like how the IoT works, right? There are sensors and actuator. Sensor means something that actually give you data. Actuator means something that you make it move, like motor things, and it go through the gateway, and the gateway will actually go to the cloud. So and eventually this cloud, the IoT cloud, can be accessed by other people or other programs. So this is why it is called the industrial IoT. My slide is not moving. Okay. Yeah. So again, I go back to my board. So so first of all, in order to use this board, we need to install the Ling. Yeah. So make sure that you actually have the ST Microelectronics Ling virtual COM port and the Ling debug. Yeah. And let me explain in slightly more details the example that I'm going to show. So in IoT, one of the popular protocol nowadays is actually called the MQTT, right? Because it is very low, because it requires very low bandwidth and very fast. In actual industrial things that I have done is a traffic light. I actually have tried to send a few hundreds traffic light, everyone at 2 millisecond interval, and the MQTT can still take all the package, right? All the data. Just that you need to implement maybe a queue system to actually queue it to the PC, because the PC is much slower. So in this case, we have edge device. So it may be a PLC, it may be sensor. And now you see the arrow here, the MQTT is having bidirection. So when we actually do like this, right, the gateway is actually becoming like a broker. Right? You can say that the gateway in this case is becoming a broker to actually send and receive all these data. So there are some concept here. So for MQTT, there is a publisher and subscriber. So for example, this edge devices is publishing the MQTT package to the broker. Then this can be actually subscribed, like in this way, by another edge device, or subscribed by the cloud. But because we are having a gateway over here that actually have multiple interface, you can also connect it through other protocol like Modbus in this case for interfacing to the SCADA system, or implement a full RESTful API for web API for software, human machine interface. So some of the speakers have mentioned already in the IDE, you can actually install the RT Thread package. In this case, I just put an example of my example. Once you go into IoT, you can actually select things like the Modbus, free Modbus. They actually give you the details. And once you actually install it, you actually can can enable it and can set the setting. Like for this case, which COM port we want to talk to. And for this purpose, we also need to install the MQTT. So on the package manager, there is this MQTT called Kawaii MQTT, which we install. And again, we do some settings. The setting that we have done here is actually to enable it and also to set the timeout thing. Okay, for this particular board I have, I'm gonna enable the Wi-Fi. Right, so under the RT Thread settings on here, you actually can go to the hardware portion and enable the Wi-Fi. Once we actually do all these settings, including installing the MQTT package and the Modbus package, we need to actually build and fresh into the board again. So in this case, I actually show the screenshot of once we actually flash with the Wi-Fi enable, we actually can see the Wi-Fi being initialized, and we actually can connect to the Wi-Fi. In this case, I connect to my home Wi-Fi, right? And then it actually have an IP address. And why I want to do so is because the MQTT will connect to internet. Okay, so before we go to the actual demo, this will be some of the setup. So once I actually connected to the Kawaii MQTT by running the KA MQTT through the package, we need to actually use a client to test. There are many MQTT clients, and this MQTT box is available as apps on the Chrome browser. So of course, when we actually have the client, you need to do some setup. In this case, what is the host? Who is the host? And then we connect to it, right? So so before I actually go to the demo, that will be my final things. Let me just explain in slightly more details. So let me just slightly go back to this slide. So as you can see, in order to make the MQTT work, someone need to post data, publish data, and subscribe to the MQTT data. So in here, it actually shows all the settings. So let's look at the red color things first. So in the settings of the MQTT box, which is the computer will actually subscribe to this topic called RTT/Jiawei/sub. Jiawei is my name. And correspondingly, this will actually, once it actually successfully run, you can see that actually it will receive the subscribe topics. And this actually is programmed onto the UtPy, the microcontroller board, by this command, MQTT subscribe. So likewise, the other way around, there is a publish, right? So for the computer, it subscribe, and for the microcontroller, it publish. So as you can see here, the line 38, we actually publish the topic RTT Jiawei pub, and for the computer, it actually subscribe the topic RTT Jiawei pub. And because the message that we actually compile and build and send is actually, this is a Kawaii MQTT text, you actually get the message. So with this, let's see the demo, right? Okay, actually I have the, let me unshare the, okay, let me just still show the screen, okay, before I showing my hardware, okay, which is just beside me. Okay, so on the, this is actually my IDE with the bot connected and it's actually running. So you see here, actually right now, I'm going to send something from the MQTT box. So let's say I say, good morning. Right, you see that the message, good morning, yeah, it's been sent. Okay, and likewise, the subscribe will actually keep on getting data because we are sending this data, Kawaii MQTT test. So of course, because this one has already been built and fresh into it, so I couldn't change the message on the fly. So this one, I'm not going to rebuild it. So I hope everyone will understand this step. So with this, right, I want to actually just show the bot. So there's another thing that I can do, right? Yeah, talking about the LED blinking, yeah, this particular exercise that's actually available online by following the tutorial by UtPy. You see that actually is doing a LED blinking. So first we actually define the LED blinking pin, and every time it actually receives something, right? Everything it receives something, it will toggle the LED, right? You can see that these two lines are actually toggling the LED, right? These particular things. So that means to say every time I actually press publish, something will happen and the LED will change. So with this, right, I actually want to just show the bot beside me. Right, you can actually take a look at this LED. Right, the light will kind of like change every time I actually press publish. Yeah, can you see that it now changed to blue color? And if I press, yeah, let me just pull it up to let you see. When I press publish, it will say good morning again, right? And the LED will change. I press again, so now it changed to red, and there is a good morning again. So let's say I put good morning 5. See the color change one more time. So okay, what is the importance of this? Is because, let me go back to the screen sharing. Okay. Sorry, before I send to screen sharing. Okay, what is the importance of this is because other than getting subscribe we can also publish to the MCU. And the importance of this is because since this is a gateway, it probably will connect to things like PLC. This is actually a PLC. Right? How it can connect is actually like PLC. Normally, the advanced one actually have a connection like Ethernet, like this. And for this board, later I will show. It even come with a I/O expansion board, industrial I/O expansion board, and that actually can connect to the PLC, to the HMI, and even to like flash and measurement instrument, right? Depending on what kind of interface that you have. So this actually will open up to all the possible industrial I/O. So with this, let me just share my screen again to conclude my talk today. Yeah, sharing my screen and then go back to the slide. So, so I want to conclude my talk with a last few slides. Okay. So in short, relative to many operating system, I would think the RT Thread is actually easy to use, especially how the way that it actually install library, compared to some other IoT system that I tried, especially those that run on Visual Studio Code. You actually will have like naming problem kind of things like I don't want to name it. Okay, right. So these are some of the resources if you are interested to actually look at this board is able to run RT Thread. So of course you can download the RT Thread Studio. You go to the Getting Started to look at the example, which is my example is basically from there. And it, like I say, it even comes with industrial expansion board that have Ethernet, IS232, IS485, CAN bus, of course I/O, and even touchscreen. Okay, with this, I actually want to end my sharing. I think I'm running ahead of time to save some time. So myself, okay, these are myself. I actually stay in Malaysia. And that's my linking. And I run a company that actually do industrial automation and software and cloud. Okay, thank you.
Well, thank you, Dr. Leo. So I just posted a note saying this would be a great time to start posting questions for Dr. Leo while we have him live. That was a very interesting presentation, Dr. Leo. Thank you so much.
All right, much welcome. Hopefully it's useful. Yeah, short and concise.
Yeah. Well, while we're waiting for questions, I'll tell one little story. My degree was in control engineering back in the late 1970s. And it was a course that in America they call a co-op course. And it means that you're in university and then you're out in industry, and in university and out in industry. Oh, and in England, we call those sandwich courses. So there were some courses where it was 6 weeks in and 6 weeks out, and that was a thin sandwich. And my course was a thick sandwich because we did 9 months in and 6 months out, and 9 months in and 6 months out. And on my second session, I was sent to a glass research center, and this was a company that made big glass molding machines and had big glass factories. And halfway through my time there, one of the factories needed to be dismantled and rebuilt because you have a monstrous brick kiln that has tons of liquid glass in it, and it's suspended in the air, and then you have the glass forming machines underneath, and the liquid glass comes out in rivers and pours down into the glass forming machines. And every 7 years or so, the brick dome collapses or fails. So they power the whole thing down, and all the workers get sent away for 2 or 3 weeks. And while they're rebuilding the furnace, they redo all the instrumentation. So all the instrumentation is upgraded every 10 years. And at that time, again, this would be like 1978, 1979. We didn't have the computers that we have today. So the automation was very low level. And all the recording was done on these massive rolls of paper that went across very slowly, and there were lots of needles going up and down, recording everything. And there was one man who had retired a long time ago, but in the factory, they gave him a building in the old part of the factory, and he was the only one who could keep these recording machines going. And he literally made tiny little gears, so the little cogs, gear wheels for them. And this was at the tail end of those recorders, I guess, because now, of course, in those days, memory was very expensive.
Yep.
You know, and we didn't have solid state drives or anything. Just tape, big reels of tape. So the way industrial control has changed from then till now, and the sort of things you're talking about here, using RT thread for industrial IoT, the whole thing about the IoT and then the industrial IoT, it's just mind-blowing to me. So we've got a question here. Where can I find the MQTT library? Is it in the RT Thread Studio?
Yeah, okay, maybe I can share my screen since I think I'm still ahead of time. Yeah, okay, yeah. So this is the IDE. So it depends on the board that you have, I believe. But for me, once you actually load it, so you can see here there is a RT thread settings. You double click on it. Yeah, it will launch the configurator. This is kind of useful. Yeah, give it some time. So here you actually can set all the hardware as well as add the library. So if I come here, right, you can see that you actually can add peripherals, you can actually add tools, you add programming language, security. I haven't played with it, and even AI, right? So IoT actually comes under here, and let's say I just click on the another MQTT, for example. They are not just one MQTT. You can actually look at the descriptions, yeah, and then add it to the projects. So once you add it to the project, like for those that I actually added, right? Let me see where is my, yeah, the Kawaii MQTT is added, right? So and because it's added, you actually will see it over here. Let me just close it because it's added, right? The Kawaii MQTT is in the configuration. You actually can like set to the some things that related to this library. For example, what is the keep alive interval in seconds? You don't want to make it very long. Okay, other than this, right, we actually also can set some libraries, right? They are like touchscreen library. I believe also there might be other library that is MQTT related, but not for this board. Okay, and for this board also the board support package that define all the onboard peripherals, right? What things it has, and also what is the GPIO. Right, so if you actually follow the tutorial, so not tutorial, as in the starting page, right? From here, they actually have tons of other example, and also for they come with tutorial to actually teach you how to actually do like firmware update over the air, right? Which is something not very easy to do with many microcontroller. But this one it actually just come with it, even come with an example. So I personally find it's very nice. So like you think that when you install the things on the factory, if you have internet to connect to it, you can actually update the firmware anytime when you think necessary. So you don't need to go on site to do it. you can troubleshoot it remotely. So these are the beauty of the IoT. The only thing is that back in my country, although all this technology is around, many factories still doesn't allow actually internet connectivity. So what we essentially have is still just the local area network most of the time. But the good thing is that the IoT portion, that the technology works the same, right? Regardless whether it's in the internal network or go to the internet, right? It still works through a network protocol. So I think that will answer your question, including a lot of elaborations.
That was great, very useful. Well, someone's actually asked me a question. Did I work with transputers? So for those who don't know, transputer was a revolutionary type of computer chip back in the early 80s. And it was like a multi-core computer, which was way ahead of its time. And it could perform many actions in parallel, which again was way ahead of its time. I mean, this was before FPGAs really got on the scene, and the first FPGAs were only 8x8 arrays of 3-input lookup tables, or 4-input lookup tables. So I didn't work with them personally back at that time, but I do communicate now with a company called XMOS in the UK, and they've taken over the transputer technology and developed it. And they now are doing all sorts of incredible things in the audio arena. And for one example, this recording is set to expire. What? For one example, there's a famous problem called the cocktail party problem. And the idea is if you've got a crowd of people in a room and they're at a cocktail party and everyone's talking at the same time, humans are really incredible about picking one voice out of that conversation and listening to it. And it's very, very difficult for computers to do the same thing. But XMOS, using their modern incarnation of the transputer technology and some very clever algorithms, they can do that. They can listen, the XMOS device can listen to a room of people talking, and it can isolate each person's voice. And once it's isolated them, it can track them as they're moving around the room. And you can select just one voice or another voice. It does it all simultaneously. You don't just pick a voice and then follow that voice. It's separated them all out. So you could just pick this voice here. If you imagine putting a camera front-end interface on it, if you were the CIA, for example, and you had a room bugged, and you had a camera, you could just use your mouse to pick that person and listen to those two people talking. And where this becomes interesting to me is I think the future is going to involve augmented reality glasses or headsets or whatever, where you can superimpose information onto what you're seeing. But there could also be an audio component where you could be, well, first of all, just the person you're talking to, the sound fades down around you, so you just hear that person. But also, if you're a spy, you could actually say to your AI, what are those two people saying over there? And it would filter everything down, and you could listen in on private conversations, which is obviously a bit more problematic. So Dale's saying the first sub-decimeter GPS receiver used transputer. Wow, I didn't know that.
I didn't know that. It's actually also my first time listening about transputer, so interesting. Yeah.
And look at the comment there. It's the migration to VxWorks and C++ was almost a complete disaster. What could be easier than learning C++ without training?
Yeah.
Oh dear. Okay, Dr. Lear, thank you so much. Dr. Lear did post his contact details, so if anyone comes up with any questions later, or if you're watching an archived version of this presentation, you can contact Dr. Leo via email and everything. Goodbye, Andre. We'll see you all tomorrow. Okay.
Yeah. Bye.
Okay, so we've got two more speakers, I think. Our next speaker is Nicola, who is a student at Palencio de Torino. And Nicola is interested in the embedded systems world and a lover of open source. And is currently working on a university team developing a prototype of a Martian rover to compete in the European Rover Challenge. Well, that's sort of exciting. So the topic of Nicola's presentation is RT Thread as the first Rtos approach to university students. So I'm going to hand this over to Nicola. Here we go.
Hello everyone, my name is Nicola. I'm currently in my first year of my master's degree in embedded software engineering at Politecnico di Torino. In the first semester of this year, we had a course about real-time operating systems, and we were asked to develop a project on RT Thread to be presented to the professor at the end of the semester. This was for many of my classmates the first approach to developing using an Rtos, which can be challenging, and more so because we were asked to modify its kernel in order to obtain bonus points. The presentation of this project needed to be like one done to a client who asked for specific requirements. Our project was about developing a stress test for the real-time capabilities of RT Thread using an Stm32 development board by ST Microelectronics. We used the latest available version of RT Thread and RT Thread Studio, and we programmed using only the C standard programming language, trying to abide by the rules of the MISRA-C standard. The board chosen by us was more than enough power and peripherals for what we needed, and was chosen mainly because we already had one, and so it was easy to program on one. We also used 3 sensors, a barometer and an IMU, communicating via I2C to the board, and a flash memory for data storage, activated asynchronously by 2 push buttons, one used to read the memory and one used to write it. In an initial design document, we proposed the usage of a Raspberry Pi Pico, which was substituted by the H7 because of better support. And we also proposed to use an SD card, which was later removed in favor of a flash memory, which was easier to use. The application had to sequentially read data from the IMU and the barometer, storing it in dedicated arrays. And this data was then processed by a benchmark. All the shared variables are obviously protected by mutexes to avoid concurrent access on the protected memory. The benchmark chosen was XenoJet Bench, which was initially conceived for multiprocessor systems and was then repurposed by us for a single-core real-time stress test. It is controlled by a main thread, which consumes the input arrays in 4 intermediate priority tasks created by the latter. The images show how the benchmark was initially conceived before being heavily modified, removing the true interest for the output values, because for our application they're of no interest, being our purpose just to stress the MPU. Substantially, the application presents a producer, a consumer, and an asynchronous task activated by a push button. Whenever one of these is activated, the task performs a write either the inputs or the outputs of the application, to the first eligible address of the memory. If the flash memory is full, it is just erased. The priority of these tasks is like the one of the consumer thread, which is the actual benchmark, causing a round-robin alternation to take place. The other task is just the reading counterpart activated by a second push button and prints the read values to the console. As mentioned before, all the shared variables are protected by mutexes, which could cause long delays when taken because of the way they modify the scheduling. Real-time constraints had to be set, which for both producer and consumer means that they need to finish before the other task begins. And if they intertwine, the variables in the benchmark are updated mid-calculation, rendering the output unstable and causing issues on synchronization. A huge leap forward compared to the previous implementation, which used asynchronous tasks, was to find a way to handle aperiodic tasks in a predictable way. To do this, we designed a deferrable server defined as a more complex task, which uses two timers. The first one is used for the capacity of the server, and the other one for the period. If the capacity of the server runs out, its priority is modified and is set equal to the idle task. So the server will run if and only if there are no tasks to run at that time. The tasks inside the deferrable server are handled in a first-come, first-served rule. Thanks to the deferrable server, the asynchronous tasks are handled in a known and predictable way, strictly controlling the execution time. This way, the interrupt routines are also quicker because they just need to push the task into a list. This results in an enhanced running time, which is 15% shorter than before. Okay, now I'm gonna do a demo of the project, connecting the H7 board, and I'm running in debug mode, but I'll just let it run. Okay, the console opened. Now, if I run the project, the LD peripherals will be initiated, and then the benchmark will start. The first thing that it will do is that it will read data from the MPU here and the barometer here. And when I press either this button or this button, the interrupt will be an interrupt will arrive in the system, and the H7 will run the deferrable server when the scheduler deems necessary. And here the system is reading the data from the gyroscope and barometer and accelerometer, and now it's restarted. The execution of Xenojet Bench started. Now if I press this button, the interrupt will arrive in the system. the data has been written in the flash, and the benchmark just keeps going, and it will go on for 200 seconds at least, as I said before. Thanks to our many hours of work and study, we reached a full mark of 30 cum laude, which is the highest grade in Italian universities. For this, I want to thank Nicolò and Fulvio, which are my teammates, and my professor Stefano Di Carlo from Politecnico. I also want to thank the Thread team for the invitation to this event, and everyone in the audience for listening. I hope you enjoyed my presentation, and have a great day.
Well, thanks to Nicola for that update on what he's been working on. It looks like the sort of thing that students are doing at university these days is fantastic. The amount of tools and the new technologies and everything that are available to everyone, it's heartwarming to see. One thing I was going to talk about, or just quickly mention before my next talk, is something that's been preying on my mind, because I get emails from students, or not students now, people who've just joined the workforce. They've come out of university, they've applied for the first job, they've got the first job, and as soon as they start work, they're landed with the most impossible task. Somebody comes and says, right, design this, or do this, or whatever it is, with no guidance, and older, more experienced engineers don't have enough time. Everyone's working so fast these days. And it makes me feel really sad, because when I graduated university in 1980, my first job was with a company called International Computers Limited, ICL. And that was like the IBM of the UK, much smaller, of course, but we were very proud of it. And my first job was I was a member of a team designing CPUs for mainframe computers. And the way ICL hired people, they hired straight out of college, and they just had one period of the year where they hired. It's 1 2-week period. So everyone started on the same day. I think there were about 30 or 40 of us. And each person was assigned to a more senior engineer who was going to be the mentor. And my mentor was a guy called Dave Potts, and I'm still in communication with him today occasionally through LinkedIn. And my task, it was the first ASIC I'd ever designed. Of course, that sounds very impressive these days, but I think these ASICs only had the 5 micron technology node, and they had about 300 gates each. So much simpler than today, but the only design tools we had was the pencil and paper. So we designed at the gate level and register level in schematics. Timing analysis was done by adding the delays together by hand. Functional verification was done by all the other engineers looking at your schematics and asking why you'd done this rather than that, and you defending it, until eventually everyone said, all right, that looks good, we're good to go. And my task was to design a barrel shifter, and you've got to remember, this was a computer, I can't remember now, I think it was a 64-bit bus, but it could have been 128 bus, and this remembers 1980, but again, it's a room-sized computer. And I was told to do a barrel shifter, which means that you can shift the whole word by any number of bits in one clock cycle. And my mentor, Dave Potts, said, okay, you've got to divide this over 8 ASICs. They're all going to be identical, but we'll hardwire 3 pins to say whether it's on the right-hand end or the left-hand end or in the middle or whatever. And I went off and created the logic to do a binary shift of any number of bits in one clock cycle. And when I came back, Dave said, "Oh, great, you know, but now I forgot to tell you, we've got to do different sorts of shifts. We've got to do logical shifts where you shift zeros in, and we've got to do arithmetic shifts where we shift the sign bit back in." So I went off and I implemented that, and I came back and he said, I should have mentioned we also have to do this for binary coded decimal. And he kept on layering things on and on and on. If they'd given me the full spec was like a book. And if they'd given me the full spec when I started, I would have given up. But because I had a good mentor who guided me to it, didn't assume I knew anything and took me step by step, it gave me the confidence to go on and be one of the world's greatest engineers, according to my mother, who is absolutely convinced I can do anything whatsoever with regard to electronics, and I don't want to disillusion her. So I was just going to say, if you ever get a chance yourself to be a mentor to someone, when a new student comes in, if you are the new student, try to find a willing and able older engineer. And if you are a willing and able older engineer, try to find a new student and actually take the time to explain things. Because when you come out of college, very often, you don't know as much as you think you do. There's a world of difference learning the theory of the automobile and the combustion engine and lying underneath one with the oil dripping on your head, wondering which bit's what. And it's just the same in electronics. So anything we can do to be mentors to other people, I think is a jolly good thing to do. Okay, our final speaker for the day is Josh So. Josh is the author of the Permanent Autopilot open source project using model-based design. He worked in Europe for 3.5 years after graduating from the University of Technology in Eindhoven. And the FMT was originally developed in his spare time, and he's currently continuing to develop it full-time as a freelancer. And the title of Josh's presentation is Model-Based Designed Autopilot with RT Thread. Over to Josh.
Hi, everyone. Presentation about the FMT model-based design autopilot project, which is powered by Thread, and I'm the author of the FMT project. So here is the content of the presentation. First, for the introduction, what is FMT? FMT is also known as Permanent Autopilot. It is the first open source autopilot system based on model-based design method, which is the main difference compared to other autopilot systems. MBD is a very powerful tool and is widely used in aerospace and automotive field. Based on MBD, FMT can be used to quickly build control system for not only drones, but also for boats, cars, or even robots. FMT is a relatively new project as it became public last year. It began from my hobby project, Starry Pilot, back to 2016. It was one of the first open source flight control systems which used Thread. FMT is involved from Starry Pilot, so it also used Thread compared to some other well-known open source autopilot systems. PS4 use Mutex, and Autopilot or APM use Qbi OS. So if you know Thread before, FMT would look quite familiar to you, and it would be much easier to use compared to PS4 or APM. We believe that a good system should separate embedded software from the algorithms and integrate with a 3D simulation environment, which is the future, I think. So embedded software developer and algorithm developer can focus on their own area. Based on this idea, FMT is separated into 3 components. First one is FMT firmware, which is the embedded system developed with C language. It contains the core software framework, such as drivers, middleware, top-level tasks, and so on. The first figure here shows the controller provided by FMT firmware. It provides lots of powerful commands to interact with the system. The second component is FMT model, which is the modeling framework which built in MATLAB. It contains algorithm and simulation Simulink models, such as inertial navigation system, also known as INS, a control model, a state machine, or also called a flight management system, plant, and so on. The second figure shows the mirror simulation built in FMT model. You can run the model in Simulink and see the simulation data, as well as 3D visualization in the real time. The last one, FMT Sim, is still under developing. It is a simulation environment based on advanced 3D engine such as Unreal. The goal of FMT Sim is to provide a realistic simulation environment with rich test things, which will make great convenience for testing. The last figure shows the hero simulation using FMT and Unreal. It can be operated like a real drone, and as you can see, the rendering, in fact, is quite nice. In a word, FMT builds a software platform that integrates embedded software, modeling, and 3D simulation altogether. The first design goal of FMT is to create a lightweight, efficient, and stable embedded system, which is FMT firmware. The second goal is that FMT is designed for MBD. So in order to achieve that, the FMT firmware provides several modules, such as log system, parameter system, and also the IPC system to support the development of the MBD. Also, the FMT model provides a platform to design and simulate your model. The last goal is to use advanced simulation technology to build a powerful simulation environment, which is FMT Sim. For this section, I will introduce the software architecture of FMT firmware and FMT model. First, this is the architecture of the FMT firmware. The lowest layer is target hardware, which contains the MCU peripheral drivers and board related files. FMT currently supports various hardware such as Pitalk, Pitalk 4, CUAV V5 Plus, and Cube Orange. So if you want to port FMT to a new hardware, you have to implement this layer by yourself. FMT also supports QEMU, so you can run FMT on your PC without need of a real board. We expect that FMT will support more hardwares in the future, which need help from the community, which is you. The driver layer contains I/O device driver, such as sensors, onboard chips. The hell layer isolates the upper layer with the driver layer, so it makes porting easier. And also we can move the common driver code to hell layer, which simplify the driver development. And the Rtos layer is Artistrat. And now we are using a version 4.0.3. In the future, we may upgrade to the latest version for components, such as MuMCM, which is the IPC module based on subscribe and publish model, as well as log system, parameter system, control system. The mob proxy provides the ability to communicate with a ground control system, such as Q ground control, via the Mavlink protocol. The models layer includes algorithms. As you can see here, we have 4 kinds of algorithms. The INS, which is also known as Inertial Navigation System, controller, FMS, flight management system, which is also known as a state machine and a plant. The algorithm can be the C or C++ code generated by Simlink model, or the handwritten code. For instance, now FMT contains two IS systems. One is base FMS, which is created in Simlink and generates C code to integrate into FMT firmware. The other one is the TX4 EKF IS system, which is written by C++. Now is perfectly ported into the FMT platform. The top layer contains several tasks. Each task corresponds to a specific functionality. For example, task vehicle runs the algorithms to control the vehicle. Task COM takes the responsibility to communicate with the ground control system via the Mablink. You can also enable or disable some tasks, or just create new one by yourself to customize your system's functionality. The next one is the architecture of the FMT model, which is a key to support the MBD. Firstly, we create FMT toolbox, which contains lots of useful blocks to speed up your model design, such as mass, coordinate transformation. The other benefit of it is that FMT toolbox is totally built with Simlink base blocks, which means you don't have to buy other commercial toolbox. The simulation model implements a meal and open loop simulation model, which enables you to do the meal and open loop simulation. In the future, we may implement more simulation model. The other most important one is the algorithm library, which contains 4 kinds of algorithms that we mentioned before. Each kind of algorithm contains 1 or more models. For example, LS could have a complementary filter model or an extended Kalman filter model. Controller could also have controller for drones, car, boat, or even for robots. The idea here is that by selecting the specific algorithm model, or create a new one by yourself, which meets your requirements, you can quickly build the control system for any vehicle using the FMT. It is very important to create the algorithm library because we can share our work and also reuse the work from others. In this case, FMT is just a platform to host various algorithms. Okay, so what is the model-based design? The definition is that a model-based design is a framework used in virtual prototyping of embedded software. MBD has evolved to overcome various difficulties and complexities that typically arise during the design life cycle of embedded software for closed-loop control system. In a simple words, MBD refers to an algorithm model built using MBD design software such as Simlink. Through graphical and code automatic generation. As shown in the diagram below, we use Simlink math blocks to build up our algorithm. We first do the simulation to verify it works. Then we can generate C or C++ code to integrate into embedded software system. So why use MBD, or what's the pros and the cons? In my opinion, I think MBD has the following advantages. First, graphical programming to improve the development efficiency. Secondly, easy maintenance and modify. Also, models are more reusable. A powerful simulation ability, such as meal simulation and open loop simulation, which we will introduce later. to improve the debug and optimization efficiency. Firstly, automatic code generation to reduce errors due to the handwritten code. Lastly, strict modeling specification. For example, for Simlink, it has lots of check for models, so which can generate a more secure system which has better security. Regarding to the disadvantages, also I list some here. First, less flexibility than coding. For example, C and C++, we can use pointer as we want everywhere, but for Simlink, we cannot use pointer. Secondly, a few mature MBD development tool, for example, Simlink, which is normally very expensive. Also, the model file is binary. Yeah, so we cannot use gitdiff, which will be a problem if we have several people to work together with a same file. But there is also some tool can help that, but normally you have to pay that also. Last one is that generated code has lower efficiency. Here I will give a big question mark here. Since based on my experience, the Simlink generated code is more efficient than most programmers and slightly less efficient than experienced programmer. So do not worry about it. Do not worry about the auto-generated code efficiency, and it's usually more robust than handwritten code. FMT supports various of simulation methods, such as mere model-in-a-loop simulation, open-loop simulation, software-in-a-loop, hardware-in-a-loop, and also software-in-hardware simulation. Here, I want to introduce them all. For more information, you can check FMT user guide. Here, I would like only to introduce mere simulation and open-loop simulation because they are very important and useful for MBD. So first for mere simulation. Mere simulation, also known as model-in-a-loop simulation, provides an efficient way to test your algorithms. It can avoid applying algorithms directly to a real hardware, which possibly become a disaster. As shown in the diagram here, the mere simulation includes the plant model, which accepts controller's output and generates the vehicle states, such as altitude, attitude, velocity, position, as well as sensor data for NS to do the data fusion. We can send the vehicle states to virtualization blocks such as MATLAB 3D, Unreal Engine, or Gazebo, whatever you like. And we can connect our remote controller to generate pilot command to control the vehicle. The biggest benefit for MEO is that we can test our algorithms in a very early stage and easily get all the simulation data for analyze purpose. It's a very cheap way to test and improve your algorithm. So we notice that the MEO simulation result is usually not the same as the real test result, because it depends on whether your plant model is accurate enough or not. So MEO simulation is not good at tuning your controller's parameter, such as PID, but it's very useful to optimize and test the model for NS, FMS, and so on. Here is the MEO simulation model, which is designed with the Simlink. it is quite similar to the diagram showed before. The FCS block here, it contains IMS, FMS, and controller model inside. And here is a demonstration of mirror simulation. Here we connect remote controller to send the pilot command to control the drone. As we can see, the 3D virtualization and simulation data in the real time. The other very useful tool for MBD is the open loop simulation. Open loop simulation provides the functionality similar to a black box. We only need to record a small amount of model input data. By recording it, we can run the open loop simulation, and we can get all the data information of the model, includes output data and also all the internal signal data, which is quite useful for us to solve the bugs and also to optimize your algorithm. This is the FMT open loop simulation model. The blocks inside the green areas, like here, and here, they are all data parsed from log file. For example, the data in the upper right corner, the INS out, FMS out, and control out. They are not used for simulation as it doesn't connect to any model. It is recorded only because we needed to compare with the simulation model output. For example, you can compare the recorded INS out with the simulation INS out result to check if they are identical. The consistency of the real test with the simulation result is very important. Ideally, it should be 100% identical, since it has the same input data and the algorithm is the same also, because the algorithm runs in the hardware is generated by the Simlink. So in theory, they should get the same result. But in practice, it's normally very hard to achieve that because limited by the embedded system's real-time performance and also the data logging bandwidth. However, FMT can ensure the open loop simulation result is almost 100% identical with the real test result, which means you can really trust your open loop simulation result. Here is a test result. The blue lines are real test results, and the red lines are simulation results. As you can see, they fit perfectly. This is because FMT has great real-time performance and efficiency to achieve that. Okay, the next section I will present some test videos of FMT. All the algorithms are developed in Simlink and generate code to integrate into the embedded system. This is the outdoor position hold and maneuver flight test. As you can see, the drone can hold its position very nicely. This is a test for auto takeoff and landing, and also return home. This is the mission mode test to fly the waypoints created by Q ground control. Let's play the video. First, we will start up our FNE firmware, and then it will connect to the Qgrund control automatically. Here we can set up the waypoints in the QGC and upload it to the embedded system. Then we can start mission. The drone would first take off to the target height, which is 10 meters. Then fly to the first waypoint, which is number 2 here. Then fly to the next one. At any time, you can click pause button to stop the mission, and then continue it. Also, you can set mode to hold to pause the mission, and then send mode back to mission to continue. Okay, then fly to its last waypoint, number 4. When finished all the waypoints, it will return to the home position and then landing. Landing. Okay, now altitude is 0, which means it reached the ground. So that's it. Okay, for the last section about the future of the project. Here is the roadmap for this year. The first goal is to build the community, because FMT is the relatively new project. So we need to improve our document first, and then we will spend more time to help FMT developers and user as well. Technically, for FMT firmware, we will continue to do the code mature to improve the code quality. Also, at this year, we have planned to support ROS or micro ROS, and also to support more hardwares. And also for port PS4 and APM algorithm, now we have already port PS4 EKF algorithm to FMT platform. In the future, we want to port more, such as control algorithm, to support more vehicles, such as fixed wing, VTOL, and so on. For FMT model, in a part of optimize current models, we plan to develop more algorithms, such as the algorithm model for fixed wing, car, and also for boat. Also, a very important topic for this year, we plan to create a 3D environment based on Unreal, which supports various vehicle simulation, and also which contains several lots of vehicle 3D model. So that's the roadmap. For the future of the project, FMT will always remain open source, and it is committed to become a universal platform for unmanned control systems. not limited to drones. I hope FMT would be able to use for car, boat, robots, and so on. So in order to achieve that, we really need help from the community to contribute more algorithms model and help us to build a more flexible and reliable embedded system. So a big welcome to join us. FMT is still a baby. It needs more support and contribution to grow up. So if you are interested about it, you can get the code in the GitHub and also document as well. And here is the link. Yeah. Okay. So that's all for today. Thanks for listening. Bye.
Well, thanks to Josh for that. It's awesome to see the sort of things that you can do with modern control systems and everything. I remember the first drone I got. It was only a little one. It was just it was a long time ago. This was before any of the modern control systems. So you could, if you took your hands off the controls, it just went all over the place. And it was very temperamental, and I took it out. I charged the batteries up, took it out into our back garden for the first day, and I was flying it around the garden, and it started to go one way, and I tried to correct it the other way, and then it went too far the other way, and I tried to correct it. And I was overcorrecting, and eventually it flew over the top of the house and disappeared, and I never saw it again. So I became very disgruntled with drones, and yeah, I'm still waiting for one that will absolutely fly itself and won't need me to do anything at all. Okay, that was an awesome day of talks. I'm really sorry that we had a couple of glitches, but that's the way things are. We're engineers. We're used to things going wrong. So at this time, I would like you to ask all of our attendees to fill out our after-conference survey. Kathy will post a link to this questionnaire in the comments area. And we really do appreciate if you take a little bit of time just to fill it in and answer, you know, what can we do better? And obviously not crashing in the middle of the conference would be at the top of the list, but yeah, I'm sure you'll be kind and gentle to us with us. Now it's time for our third Lucky Dip giveaway for today. And I'm delighted to announce that the winner of today's third board is Nuno Felicio. So Kathy will be getting in touch with you with the board and everything, or to get the board to you. Kathy will also be posting a link to the next Lucky Dip. So this is a chance to win the next board. All you have to do is click on the link that Kathy is about to post in the chat portion of the interface, and we'll be announcing the winner of this Lucky Dip during the first break tomorrow. There we go. Thank you, Kathy. So there's the survey there and the Lucky Dip link. Also remember that we're going to have, well, we've got this Lucky Dip. We're going to have, excluding this dip, we're going to have three new ones tomorrow. And in addition to all that, at the end of the day tomorrow, we'll be having a super dip. And the lucky winner will be presented with one each of all of the development boards. So I'm going to sign off now. Thanks very much for all the people who've been staying up late, like Cherie, you know, and all the people around the world, you know, staying up till the early hours of the morning to watch this. Yeah, we really do appreciate it. We love having you here. So I'm going to sign off now, and I very much hope to see you all back here tomorrow for the final day of this 3-day extravaganza. I'll see you then. Bye now.